Welcome back, curious coders. Today I'm going to talk about design patterns in Java. When you're coding in real life, it's not just about making the code work. Anybody can write code that just works. But your code should also be scalable, reusable, and most importantly, easy to maintain. That's why design patterns exist. These are not frameworks or libraries or ready made code snippets. These are proven solutions to commonly occurring software design problems. Basically, what this means is that you don't have to reinvent the wheel here. There are experienced developers out there who have already figured out the best practices for you. You just have to use them. So in this video, I've compiled 11 of such design patterns. These are the most important ones for interviews. And just like my other videos, this video will also be filled with real world coding examples and hands-on practices. And trust me, watch till the end and you will never have to learn them again. Okay, so let's get started. So let's start with the very first one, factory pattern. So what exactly is factory pattern? It is a design pattern which is used to create objects without exposing the object creation logic to the client. Alright, let's understand what this actually means. Suppose we have an interface and multiple classes are implementing that interface. Now different clients in the application might need objects of these implementation classes. So factory pattern says that the client should not be the one who is creating objects of these classes. Instead, we introduce a factory class in between. And this factory class contains the complete object creation logic, meaning it decides which class's object should be returned based on the requirement. So the client simply asks the factory for an object, the factory handles the creation internally and provides the object to the client. Now you might be thinking that okay, we introduced a factory class in between, but why do we actually need this pattern? So that's exactly what we are going to understand in this video. I've already given you a brief. Now we'll start with a real world example which has some problematic design. Then one by one, we'll start identifying the problems and solving them, and eventually we'll naturally arrive at the factory pattern solution. With this approach, you'll never need to memorize it blindly, and you'll be way more confident to explain this pattern in your interviews. Suppose you are building a food delivery application like Zomato or Swiggy, and in your application, you need to have some notification system because you'll definitely be sending some notifications, right? Like the order has been placed or order has been accepted or preparing your order. Okay, things like these. So for that, I have created two different classes. We have email notification and we have SMS notification. Okay, now I have another class, order service. Basically, this class handles the ordering, and after the order has been placed, then it sends the notification. Okay, so as of now, we are only going to talk about the notification part. Okay, so what it does is we have two different objects, email notification as well as SMS notification, and we have two different methods. Okay, now what is the problem with this design? First of all, the biggest problem is that we have tightly coupled order service with both email notification as well as SMS notification. Okay, because we have created their objects directly over here. Alright, now the problem with this is that let's say in future we want to add WhatsApp notification. So for that, I will again have to create an object and I will again have to add a method. Okay, similarly, if we add push notification, then there will be one more method. So this class will become huge. And another thing is that we are adding a functionality in the notification logic, but we have to change the code in the client as well. Okay, so that is not right. The code in the client should not have been changed. Okay, so for that, first we'll solve this. What we can do is I will add some abstraction on these classes. Okay, so simply I'll just create an interface notification and I'll add a method void send. Okay, like this. Now both these classes, SMS notification as well as email notification, should implement this interface. Okay, implements notification. Alright, now this order service does not have to be tightly coupled with this. What I can do is I can just remove all this and we can just simply take notification, and we can have a single method that says public void send, and here I will just call notification.send. Okay, let me name it send notification. All right, simple. So this is how we solve the problem of tight coupling. Okay, now we are just, this order service is only dependent on this notification, and using this, it is calling this method. Okay, now see, we have to somehow give a logic that which particular notification should it be. Okay, we have loosely coupled it, but still we need to give some logic. Okay, so for that, what I can do, I'll just simply take a type, let's say string type, and I'm saying if type dot equals, let's say email, then this notification should be equal to email notification. Okay, and if it is of the type, let's say SMS, then this notification should be equal to SMS notification. All right, so this will be my logic. What I'm saying is that if this type, which I will pass from the, let's say from the main class, and this type, if it is equal to email, then we'll have an email notification object. Otherwise, we'll have a SMS notification object. Okay, and then using this notification, we'll just call the send method. Okay, so is my problem solved? No. Still, there is a problem with the design, and that problem is that why are we having this object creation logic here in this client class? Okay, factory pattern says that this logic should not be present over here. Instead, we should have a separate class for this logic. Okay, but why? See, let's say like this order service, we have one more class, delivery service. Okay, now this is another client, and it also wants to have some notification objects, because let's say after delivery we want to send some notification that out for delivery or reached your location, near to your location. Okay, things like these. So this delivery service will also be using this notification, and it will also have to have some logic to create the object. Okay, so you can see that there is duplicacy of code, which we don't want, and basically this logic of object creation should be independent of the client. Okay, client only wants to send the notification. It should not be the one who is responsible for creating the logic of how to create the object. Okay, that is why we need a factory class in between. Okay, so what I'm gonna do, I'll just simply create another class and we can call it, okay, I'll create a class and we'll just call it notification factory. Okay, like this. And the logic that we added over here in this order service, we can have this logic over here in the factory. Okay, and what it does is it will just simply return. All right, so we'll have a variable string type. If type is email, then it will return the email notification object. If type is SMS, then it will just return SMS notification. Okay, otherwise we could just throw some error. Okay, it means that it is some invalid type. So throw new, let's say illegal argument exception, invalid type. Okay, cool. So this is how factory pattern works. Basically now I have a method which is present in this notification factory, and this method is actually creating the object. Okay, now the client, what does the client have to do? Client can simply ask for an object. Okay, so let's say if we want to send notification using this client, and let's say the order service has decided that it wants to use the email notification. Okay, so it can simply use this notification factory, and instead I can just make this method static like this, and this notification factory is equal to dot send notification, and here I will pass email. Okay, like this, and this will give me an object which will be of the type notification, so there is no tight coupling. Okay, let me call it notification like this. So this order service will directly use the notification factory instead of using the notification. Okay, and this factory will be responsible of having the object creation logic. Alright, and here I can, let's say this client wants to use email, so we'll pass email, and then using this notification, we'll just call the send method. Okay, this is how the design should be. Similarly, in the delivery service as well, let's say delivery service wants to use SMS. Okay, so what we'll do, we'll just remove all this and we can directly use the notification factory dot send notification, and here we pass SMS. Alright, this will give me a method, this will give me an object notification, and using this object we will just call the send method. Okay, so the client is not worried about how the object has been created. Okay, the client only sends this type. Okay, this is in the contract that client will have to send the type, and this factory will automatically create an object of that. Okay, so the object creation logic that is only present in this factory, it is centralized. Any client can now come and they can simply call this method and they can take whichever object they want to take. Okay, this is how this pattern works. Now there is one thing, you might argue that let's say if the client wants to have both the notification system. Okay, here we have just passed the SMS and in this order service we have only passed the email. So it might be possible that client might be needing both these cases or a different type of case. Okay, so we can have different type of methods for that. It's not necessary that the creation should have to be like this. We can have different methods over here. Okay, so let me show you. Let's say I want to send multiple notifications. Okay, so for that, instead of a single type, I'll take a list like this, and using this list we'll traverse on this list first. Okay, so for, let me call it types. Okay, for every type I can just add this logic over here inside the loop. Okay, and we'll not return this, we'll simply return a list of notification, and here I will declare list of notifications is equal to new array list. Okay, and here we are gonna add this. Okay, in the notifications I'll keep on adding the different objects. Okay, so whatever we pass in the types, all these will be added over here. Okay, so as of now we only have 2, but you can assume that let's say there are a lot of type of notifications. Okay, notifications dot add new SMS notifications. Okay, simple. And in the end I will just return my list. Okay, return notifications. Cool. So now if my order service, let's say it wanted to have both email as well as SMS, so we can just call this method new. Basically we can just pass on the list. Okay, so we have new array list, arrays dot as list, and here I will pass both email as well as both SMS. Okay, like this. Okay, what's the issue? It says required type notification. Okay, list of string. Yeah, so this will be now a list of notification like this. We'll have notifications, and again we can loop on these. For every notification inside these notifications, we can simply just call notification.send. Okay, so this is how you can change your design. Alright, but the main point is that all the object creation logic that should be present in this notification factory, whether the logic is like this or whether the logic is like this, or maybe it could be some different logic, but all of that should be present here in the notification factory, and the client should only see this class, should only talk to this class, and using this class it should just fetch whichever object it want to fetch. Okay, whether it is SMS or email or both these objects. Okay, anything can be done, but the client should only be using this notification factory. Okay, this is how it works. Next, let's look into abstract factory pattern. It is a design pattern which provides an interface for creating families of objects without specifying their concrete classes. Basically, it is an enhancement over the factory pattern where instead of a single factory creating all the objects, we use a factory of factories to create related groups of objects. Now, before moving towards the abstract factory pattern, there is one more important pattern in between: factory method pattern. Yes, there are actually three things: simple factory, factory method, and abstract factory. So far, the code that we have seen is actually simple factory. So then what is factory method pattern? Factory method pattern defines an interface for creating objects and allows subclasses to decide which concrete object to create. In simple words, instead of creating objects directly using new, we delegate object creation to child factory classes. Alright, so let me show you. So in the simple factory, what we have done is that we have written all the object creation logic inside this class notification factory. Okay, and but how are we doing that? We are just adding if else conditions, and that is how we are just returning these objects. Okay, but right now we only have two type of notification, but let's say in future we have multiple different classes. Okay, so then we'll have to add more conditions and eventually this class will become huge. Okay, so it will break the single responsibility principle. Alright, because this code will eventually become overcrowded and we have many if else conditions. Okay, so the factory method says that we should create this class as an interface, and for every type of notification we should have different implementing classes. Okay, that is what factory method pattern says. Alright, so let's do it like that. I'll just simply change it to an interface and we can simply have a method that returns a notification and we can say create notification. Okay, so we'll not take any type. I will just simply leave an abstract method over here. I'll remove all this logic and we can have two different classes implementing this factory. Okay, so let's say I call one class as email factory, implements notification factory. Okay, it will just implement this method, and similarly we can also have SMS factory. Okay, so we will just return the SMS notification object from here, and from this email factory I will return email notification. Okay, so this is what factory method means, that this notification factory is also an interface and there are two different factories actually implementing it. Okay, and they return their respective object. Alright, so I will have to make changes in the client as well. In this delivery service, now I don't have any abstract method, so I will just simply create notification factory object like this. Let's say I want email, so I'll take an email factory, and using this factory I will call the using this factory I will actually create notification like this. Okay, so this will return me a notification object and I will just extract it in a variable. Using this notification I will call the send method. Okay, so now this is how we will do the implementation. Okay, so if we need an email type, so then we'll create an object of email factory, and similarly in this order service, let's say I just simply need a factory which is of the type SMS. Okay, so I will take new SMS factory. Now using this factory I can create notification, and then this will return me an object of notification. Okay, using this I will call notification.send. Alright, so you will see that this create notification has two different implementations, and since this one is an object of SMS factory, so it will actually give me this object. Okay, return me new SMS notification. Okay, and using that I called the send method. Okay, so let me just run my code. Great, so you can see sending SMS and sending email. Okay, now from this point, it's very simple to take this pattern to the abstract factory pattern. Okay, and then it will be much clearer to you that why exactly did we changed it into two different classes. Okay, why did we actually make factory of factories? All right. So let's say that as of now we only have notification. So we can consider it as our product. Okay, we have a product notification. But let's say I have a different product and that is template. Okay, like we have different types of notification. Similarly, we have different types of templates. Okay, like an email template or an SMS template. Okay, so for that, I will have to create one more interface, template. Let's say it has a method void format, and it also has two different classes. Okay, two different child classes. So let me just create them. We have email template, which implements this template. All right, so we can just print system.out.print formatting email. Okay, similarly, I'll just create another class which will be SMS template. Okay, so this will be formatting SMS. Okay, so like notification, now we have one more product which is template, and this interface also has two different implementations. Okay, so you can consider it like this, that we have two different products and we have two different families. We have an email family and we have an SMS family. Okay, inside the email family, we have two classes. We have email notification as well as we have email template. Okay, email template and email notification. Similarly, inside this inside the SMS family, we have SMS notification and SMS template. Okay, this is how you have to visualize it. Okay, so when we have families of products or families of objects, at that point of time, abstract factory pattern actually comes very handy. Okay, it comes into use. Okay, so I'll show you. Because we created two different interfaces for this factory, we had this email factory and we had the SMS factory. So now it's very easy for us to actually plug and play the template thing. Okay, because here I can just add another method. Okay, first let me add in the factory. I will just add template and I can add create template like this. Okay, so in the email factory, I can simply implement this method. Let me implement it like this, create template, and from here I can return the email template because this is the class for the email factory. Okay, for the email family. All right. Similarly, in the SMS factory, okay, where is the SMS factory? Yeah, here again we can implement this method, which is create template, and here I can return new SMS template. Okay, so because I have divided this factory into two different factories, so now I'm able to add different products if I want to. Okay, so in future, if we want to add one more product, we can simply do it because our factory logic was already divided. Okay, so whenever we get a chance to divide our factory into two different families, then we should do that and we should be using the abstract factory pattern. Okay, so this is what abstract factory pattern is. It's similar to factory method only. The thing is that generally we use this pattern when multiple products are there. Okay, that is the only difference. Okay, but the crux is this much only, that the base for this abstract factory pattern is actually the factory method pattern. Okay, so let me just complete the code. We will also make changes in the client. So using this, I will just fetch the factory. So we have factory.create notification. Similarly, I can get the factory.create template. Okay, and this will return me the template. All right, using this template, I can call template.format. Similarly, in the order service also, I will use factory.create template, and this will return me a template. And using this template, I can just simply call template.format. Okay, let me run my project. Great. So sending SMS, formatting SMS, sending email, formatting email. Okay, so basically we divided our code into two different families and we had two different products. So that is where the best pattern that we can use is the abstract factory pattern. Alright, now let's look into builder pattern. So what is builder pattern? It is a design pattern that helps us create complex objects easily by keeping the object creation process flexible, readable, and maintainable. In simple words, instead of passing multiple parameters in a huge constructor, we build the object piece by piece using a builder. Now this is just theory, but as we have done in all my videos, we'll first look at a problematic approach, understand what issue we are facing in the real world, and then work our way towards a better solution. The better solution that we'll reach will naturally be the builder pattern solution. Alright, so let's get started. So I have created a class user which has three different fields: name, age, and email. We have a constructor that takes all the parameters and it initializes all the fields. I have also added a toString method. Now this comes into play when we will be actually printing an object of user. Okay, so at that time, this method gets called internally. Okay, now I have taken three different clients. We have email service, we have login service, and there is user migration service. Okay, in all these clients, we are creating an object of user. Okay, like in login service, we have this method register user that takes all these fields, and using them, it creates an object of user by just calling this constructor. Okay, similarly in the email service as well, we are creating a user by calling the constructor, and in user migration as well, we are creating a user. Okay, so in the main class, I have just called these clients and their respective methods. Okay, so if I run my project, great, you will see that all these methods are getting called one by one, and we have all these print statements. Okay, so welcome email, user migrated, and user registered successfully. Okay, now let's say in the login service, a business requirement comes that along with the name, age, and email, we also want to send the city information of the user. Okay, so what can I do? I'll just simply add a field string city, and I want to pass this information to this user. Okay, so first let me add it over here as well. Let's say the city is Delhi. Okay, now I want to pass this information to this user object. Okay, so what I'll do is first I will have to add this field private string city like this. And now since I want this to be passed over here, so I will have to add this field in the constructor as well. Okay, so I'll just add this field over here, string city, and let's say I also add it in the toString method. Okay, because then we'll be able to see it when it actually gets printed. Alright, cool. So I have added this field here, and in the login service, I have passed it from here to here, and in the main method as well, we are passing this field. Okay, now if I run my code, great, you will actually see that we face an exception. So what exactly is this? See, in these two clients, in the email service and in the user migration service, they are still calling the constructor which has only three parameters. Okay, but we added this fourth parameter and we did not, change anything over here. So that is why we got a compilation issue. All right, so this was the problem of backward compatibility. We tried to add a field in this class user, and since this constructor was called by multiple clients, so it was not enough that we just added it over here. We have to make it backward compatible and we have to rectify it in every client, right? So what can we do? Let's say in this user migration service, I simply add a city, maybe Dehradun. Okay, and in the email service, let's say I don't want to provide the city information over here. Okay, for some reason, I don't want to specify the city over here. So what can I do? Maybe I can pass a null value. Okay, so you can see that now the compilation issue is gone. Okay, we have added a city in the user migration service and we have made this email service as null. Okay, so the problem is solved, but this is not a good design. Why? Because see, first of all, as of now, there are only 3 clients. But let's say in a real application, there are 10, 20, 30 clients. So how many places will you actually rectify? Okay, you just want to add a field here because of one client, and you have to change the code in so many places, and then you will have to test it also. Okay, so this is not backward compatible. And another issue is that maybe even if you go out and you rectify at every place, but passing this null value is not a good solution. It is just a workaround. Actually, this client only needs 3 fields, but we are saying that this user class has a method that takes 4 fields. So you have to use it like that. Okay, so this is just a workaround that okay, then I'll just pass null. Alright, but in reality, we should have given this client a method that takes only 3 fields. Okay, that would be a better solution. Alright, so let's do that. Maybe that I don't change this constructor. Okay, I keep it like this so that it's backward compatible, and I create one more constructor, and this time I take all the 4 fields. Okay, so this is another solution. Now what happened is that in this email service, let's say the code was like this. Alright, so it still works because we still have this constructor, and in the login service in the migration service as well, I need not to pass this. It would have still worked. Okay, like this. So now 2 of the clients are actually calling this constructor, and one of the client is calling this constructor because it needed a new city field to be passed. Okay, but still the solution is, this is a better solution than the previous approach, but still it is an incomplete solution. Why? Because see, as of now we only have these 3 to 4 fields, but let's say in future we have 10 to 15 fields. Okay, so how many combinations will you make? Maybe a client comes and they only want 2 of these fields, and then another client comes who want 4 or 5 of the fields in any combination. So how many constructor are you gonna make? Okay, this class will become huge and the code will be quite messy. Okay, so that is where builder pattern comes into play. Okay, this is exactly the kind of situation which builder pattern solves. So as I said earlier, instead of passing multiple parameters in a constructor, we'll build our object piece by piece using a builder. And for that, we'll create a separate builder class. Alright, so let me show you how. Basically, we don't need different combinations of constructor. We'll only keep one constructor which has all the fields, and to build my object, I'll create a separate class. Okay, so I'll create a separate class and I'll call this user builder. Alright, so what you need to do is, first thing is you will copy all the fields from here and you will add the fields over here. Okay, then we can simply generate setter methods for all the fields. Alright, so remember all the steps. Okay, this way you will never forget how to use the builder pattern. Alright, so let me just first highlight only the syntax problem. Yeah, okay, so first add all the fields, then create all the setters. Now the thing is, the trick to this builder pattern is that instead of void, you have to make a little change. Okay, so what I'll do is, instead of returning void, we will actually make the return type as user builder. Okay, and here we will return this keyword. Alright, similarly here as well, I will make the change in every setter method. Okay, and don't worry, it will be clear to you why exactly we are doing this. Alright, so for every method, I have just simply changed the return type and we are returning this keyword. Okay, now in the main method, what I'm gonna do, okay, not in the main, basically in my clients. Okay, let's take user migration service. Alright, so we will not build the user like this. Okay, because see, it needs only 3 fields, but actually we have 4 different fields. Okay, we have only this constructor. Alright, so let me just not use the constructor. First, I will build an object of user builder. Okay, like this. And using this user builder, we will eventually build the user object. Okay, I'll show you how. Basically, what I can do, using this builder, I have so many setter methods. Okay, so let's say, Okay, let me just first do one thing. I need the fields actually. So let me just keep it so that I can copy these fields. All right. Okay. So user builder is equal to new user builder. Now using this builder, I can call any of the setter methods. Okay. Let's say I called set age. Okay. So age was 30. Okay. I will pass 30 over here. Now the trick is that this setter method, what it actually does is when this method was called, it will just populate the age. Okay, so this age is now populated and it will return this. So what exactly is this? This refers to the current object. Okay, you must have studied this in the OOPS concept, that this refers to the current object. By current object, what I mean is the object that actually called this method. Okay, so this method was called by this builder object. So what exactly is happening? Builder is calling this method, age is being populated, and the same method is being returned in this from this method. Okay, so this builder calls the set age gets populated, and the same method gets returned. So the benefit of this is that since this set age returns builder only, so I can again call another method. Okay, let's say this time I want to call set name. Okay, so this is the beauty of this pattern, that this builder keeps on returning and I can call the method in a chain. Okay, so now let's say I call set name Rahul. Now again, the set name will return me a builder. Okay, so the name will be populated this time and the builder will be returned. All right, so now I can set my email. Okay, which is this one, like this, and that's it. I don't want to set the city. Okay, we have a method to set city, but I will not call that because in this case, I don't want to call that. Okay, simple. So let me just remove this first. Yeah. Okay. So this is how we can simply create a builder. Okay, let me just write it properly. Yeah. Okay. This is how I created a builder, but we still don't have the user object. So how will I get that? Now see, we have this constructor user. Now instead of taking all these fields, I could have just simply taken a user builder object over here. Okay. And what I'm saying that this user builder also contains all these fields. So just take this builder and using this builder, get the field. Okay. So we have this builder.name. Okay. I will have to make it not private. All right. Like this. Yeah. Great. So using this builder, I can fetch all the fields. So the builder.name will be populated in this name, which is actually the name of the user. Okay, so using the builder, now I'm populating the user. Okay, and builder was populated when we created this object. Okay, here in the user migration, here when we created the object, builder is already populated. It has only 3 fields. Okay, we didn't populate the city, but now using this builder in this constructor, I can actually populate the user object as well. Okay, so I'll do it quickly. Builder.age, similarly builder.email, and we have builder.city. Okay, so we are populating all the fields whichever there are. Okay, now this builder as of now in the object, it has only 3 fields. So these 3 will be populated. City will not be populated. Okay, this will just simply return null. So city will be equal to null. But that is not a problem. Okay, because for this user migration service, we didn't want the city to be populated. Okay, so this is how the design is. But now we only have this builder for now. We still have to call the constructor. Okay, so I'll show you user is equal to new user, and here I will pass the builder. Okay, that's it. This completes the builder pattern. Now in this user, we have passed the builder, and this builder has age, it has name, it has email. So name, age, email will be populated in these 3 fields. The city is null, so the city will be empty. Okay, but we can still call this method even though the city was empty. Okay, because we only need to pass a builder object. We didn't have 4 arguments, so we didn't have to explicitly pass null. Okay, that's the difference. Alright, so similarly, I'll change in other services as well. Let's say in the login service, now here we need all the 4 fields. Okay, so what I'll do is I'll just simply directly write new user builder dot, let's say we set the name. Here I pass name. Similarly, we set age Okay, the indentation is not right. Okay, now dot set email. So we set the email, and we also set the city here because here we needed the city. Okay, like this. All right. So this is a new user builder. Now where do I need to pass it? Actually, I'll do it in a single line only. This time I create a new user, and in this constructor I pass this. Okay, I hope it's clear to you. We created we called this user constructor, and inside this constructor we needed a builder object. So I have directly called new user builder and I have passed all this. Okay, like this. All right. Similarly, in the email service also, I'll quickly change it. So we'll create it like this. User is equal to new user, and here I will take new user builder dot set email. Email will be this aman dot okay. Similarly, we'll set age, which is 35, and we'll also set the name, which is Aman. Okay, simple. I'll just remove this. All right. So you can see how easy it is now. We can just call whichever method we want, and we can just set only the field we require. Okay, and it is so easy to read as well. Okay, we clearly know that which all fields are set and which one is not set. All right. So now let me just run my code again. Okay, I guess I've made the changes everywhere. Yeah. So if I run it, you will see, great, that it still runs properly. So in the email, we have Aman, age is 35, and email, and city is null because we didn't pass the city. Similarly, in the migration also, we have name, age, and email, but city is null. But in the login, we have name, age, email, as well as city. Okay. So you can see that we only created a single constructor. We only have a single constructor. We have a different builder class which has methods to create all the fields separately. Okay, and we can just use that, and using that we can create them in a chain like this. Okay, now there are a bit of improvements that I can do in that. Now let's say that this user has this constructor which is public. Okay, and we already have a logic to build our object in the user builder. So what I need to do is, I simply don't want to use this at all. Okay, I don't want any client to call this constructor directly. Okay, so for that, what I need to do, I will make this method as private. Okay, now see, the problem is that if it is private, then how will we actually call it over here as well? Okay, so that's the case, we will not call it. What I'll do is, I'll simply take this user builder class. Okay, so this is just a improvement on the builder pattern. Okay, you don't need to worry about what we are doing now. Okay, but this is another way of writing this. Okay, so in this user class only, I will create this class as a child class. Okay, generally we write it like this, and this will be a child static class. Okay, and I will create a method that returns a user, and this method will be build, and from here I will call the user. Okay, and here I will pass this. Okay, let me explain. What I did was that I don't need this user builder anymore. Let me just delete it first. Okay, all right, what I did was I made the constructor as private. So now this method cannot be called outside the scope of this class. Okay, so that's why I added this user builder inside this class only. Okay, and we can still call user builder outside the scope because I made it public. So somehow I need to give one method that the clients will call to actually create the user. Okay, because now they cannot call this constructor. Okay, so that method is actually this one, this build method. This method the clients will call, and in this build method internally I'm calling the constructor only. Okay, so I'm just calling this constructor, and I'm passing the current object of builder, using which all these fields will be populated. Okay, so this is a bit of an improvement in the design. All right, so let me make the changes in the client. Okay, so now I cannot call it like this. Instead, I will have to say new user dot user builder. Okay, so this user builder is actually a child class of user, so that's why I called new user.userBuilder. So at this point, a user builders object has been created. Okay, this user builders object will be created. Now using that, I can call the methods of user builder, which are the same methods. We have set name, set age. So I'm doing nothing different. I'm just calling these methods, set name, set age, set email, set city. But after all this, in the end, now this set city returns a user builder. Now using this, when I've populated everything, I will have to call the build method. Okay, so at this point, I will just simply call build and semicolon. That's it. Okay, you see how clear this is and how readable this is, and it has become so simple. We didn't even have to create a separate class. We only created a builder class here in this user itself. Okay, similarly, I'll make changes in other classes as well. Okay, so this time pay attention and you'll actually get to learn how we exactly did that. Okay, so I'll just do it again. Let's say we are creating an object. We want user. Okay, and I say new user.userBuilder. Okay, so we have created an object of user builder and we have to call it like this because user builder is a child class of user. Okay, then I call dot set, let's say age, which is 30. Then I call dot set name, which is Rahul. And then I call set email, which is this. Let me copy. Alright, like this. I'll just change the indentation. Alright. And in the end, when everything is populated, everything that I wanted to populate, now I have this user builder. Using this, I will call the build method. Okay, simple. Alright, and let me remove all this. Great. So eventually I got a user. Alright, now which is the last service? We have this email service as well. Okay, so I will just simply say it like this, new user.userBuilder. And eventually in the end, we will just build. Alright, cool. So the advantages are that now we don't have to have different combinations of constructor. Okay, like in this user, earlier we had to have a lot of constructors. Okay, now there is no need to do that. We can have a single constructor with all the fields, and even that we can make private. Okay, and another advantage is that the code is quite readable now. Okay, it is very easy to read because imagine there are 15 fields and you were calling a constructor. So you would have written 15 fields like this. Okay, and let's say they have similar types of return types. So maybe if you just by mistake swap those fields or add a field one before another, so it might be wrong. Okay, there could be bugs or conflicts. Alright, but here it is quite easy because it says set email, so you will definitely add email over here. Okay, similarly in set age you will add age. Okay, so readability is better, there is less chances of having a bug, and of course the main reason is that we don't have to add multiple constructors over here. Okay, and yes, this is backward compatible because let's say in future I want to add one more field, so I can add it here in this constructor and I will have to add a setter over here. Okay, I'll just show you. Let me just add one more field. Okay, so let's say we have address. Okay, so what I need to do is I'll simply say this dot address is equal to builder dot. Okay, in the builder I have not added. Let me add in the builder as well. Okay, so string address, and I will create one more setter method. Okay, so I have to do a lot of changes, I know, but I have to do all these changes in this user class only. Okay, you will see that we will not have to make a single change in any of the client. Okay, let me show you. String address, and this will be this dot address is equal to address. Okay, so I created a setter for this address. I added this address in the builder, and I will, from this builder, we will populate it in this main user. Okay, like this. And that's it. Our address have been added. I can maybe add it in this toString as well. Okay, that's just for printing. But yes, in the clients, you will see there is no issue now. Okay, there is no backward compatibility issue. you can simply see that everything works fine. Alright, I'll just show you. We can run it as well, and you see everything works fine. Okay, so these are the advantages of having builder pattern over our normal constructors. And a bit of a disadvantage is that yes, we will have to create a separate class like this, even though this class is inside user, but we will have to have this additional logic. And even if we add a field, then we will have to add it here, then again in this builder, then we will have to have a setter method. So that is a bit of a drawback, but yes, it has a lot of advantages. Okay, now let's look into singleton pattern. So what exactly is singleton pattern? In simple words, singleton ensures that only a single object of a class is created throughout the entire application. Now you might think, where do we actually need this? We do have some real world use cases, and I'll definitely talk about them in this video. But more importantly, what we really need to understand is, how do we actually implement this pattern? How do we actually make sure that only one instance exists in the entire application? Now, implementing singleton is actually not that difficult, but the real challenge is that some implementations have some loopholes, some drawbacks, and in certain scenarios, the singleton pattern can actually break. So in this video, we'll go step by step towards the best solution. First, we'll start with the most basic implementation of singleton. Then we'll move towards a better approach using lazy initialization. After that, we'll dive a little bit into multi-threading because we might be facing some thread safety issues. So we'll see how synchronized helps us solve the issue. And eventually, we'll reach one of the most important singleton design, the double checked locking mechanism. So by the end of this video, we'll not only know what singleton pattern is, but also how to properly implement it in real world applications and what mistakes developers usually make while implementing it. Alright, so let's get started. So let's say I created a class calculator which has two fields A and B, and we have a method sum that returns the sum of both these fields. Okay, so is this class singleton? No. Why? Because I can create multiple objects of this class. Okay, so I can just create an object like this, calculator C1 is equal to new calculator, and similarly I can create another object, calculator C2 is equal to new calculator. Alright, so I can create multiple objects for this class, hence it is not singleton. And using these objects, I can just simply define some values for these variables. Okay, let's say C1.b is equal to 5, and similarly we have C2.a is equal to, let's say, 7, and C2.b is equal to 3. Alright, so if I just call the sum method and print the output, so you will see that we will have actually two different sum. Okay, obviously because these two are independent objects. Okay, similarly I'll just also print C2.sum. Okay, if I run my code, great. So you will see that we have two different outputs because we defined different values for A and B. Okay, now how can we make this class singleton? See, the first thing is that as long as I can call this new calculator, I can create multiple objects. Okay, that is clear to me. So what I need to do is, first thing is that I should create a constructor and I should make that constructor private. Okay, so let's say I just generate a constructor, okay, like this, and what I should do is that instead of this constructor as public, I should make it private. Okay, so this solves a problem a little bit. Now I cannot create an object of this class calculator outside the scope of this class. Okay, so in this main, you will see that now I get this error that calculator has private access. Okay, so we have made the constructor as private. Okay, but now the problem is that I cannot even create a single object. Okay, because now since the constructor is private, so I cannot create even a single object, but for singleton, I need at least one object. Okay, so what to do? So see, I cannot call this method outside the scope of this class, but I can still call this constructor inside this class. Okay, so maybe if I can create an object over here and find a way to pass that object outside the class. That may be work. Okay, let me show you. Let's say I just simply create an object private calculator obj is equal to new calculator. Okay, like this. So I can call it like this because this calculator has private access and this method can be called inside this class. Okay, that's why I was able to create this object over here. Okay, now somehow if I create a method and make it public, that simply returns, let's say, let me call it get instance. Okay, I can call it anything, but let's say I call it get instance and it just simply returns this object. Okay, so will this approach work? I guess yes. Now this method can be actually called outside the scope. So instead of this new calculator, I will just call get instance. Okay, like this. But wait, I cannot call this method directly over there. Okay, for that I will need an object of calculator. And here we go again. We are still stuck because we cannot create an object of calculator. So how will we call this method? Right. So see, the solution to that problem is that I can make this method as static. Now why? Because if I make this method as static, now I can call this method just by the class name. Okay, like this. So this problem is solved. Now this method getInstance can be called outside the scope and it can be called directly using the class name. Okay, so here as well, I will just take calculator dot get instance. Okay, now since this method is static, so this obj also have to be static, otherwise I cannot use it over here. Okay, so I will just make this object as static. Okay, and that's it. You will see there is no issue now. I have created an object inside this class and this method is returning the same object whenever it is getting called. Okay, so these are actually not two different objects. Both C1 and C2 are two reference variables who are pointing towards the same object. Okay, and I can prove it to you this time if I'll run my project. Great. So you will see that the output is same for both. Okay, why? Because first initially the value of A and B was 10 and 5. Then C2 changed it to 7 and 3. But this time C1 and C2 are not independent. They are pointing towards the same object. That's why the value got changed for both these references. Okay, so that's why the value is 10 and we got this output. Okay, so this is how we can implement a basic singleton class. Okay, so the steps are, we have to make our constructor as private. We have to create an object inside the class. We have to give a method that returns this object and we have to make it public as well as static. And since this method is static, so this object will also be static. Okay, this is how we can implement it. So the code that we just saw was the basic implementation, but there is a drawback in this approach. Let's quickly understand what that is and move on to the lazy initialization approach. So in the basic approach, what we did was we created an object eagerly inside this class. Now what do I mean by eagerly? It means that whether or not this method will be called, this object will always be present in the memory. Okay, so let's say that this method was never called. Okay, I'll just comment this part. So still this object is present in our memory. Okay, so it's kind of wasting our memory. Now as of now we only have two fields in this class, but let's say there are many fields. Okay, it is a very populated class, it's a huge class. So in that case this object will be very heavy and it will waste the memory unnecessarily. Okay, because no one is asking for this object yet, but we have still created it at the time of loading of our class. Okay, because it's a static field. Alright, so this is called eager initialization and this is the drawback. So a better solution is that we should do lazy initialization. Okay, so how to do that? One thing is that whenever we are invoking this method, then only we should create this object. Okay, this is what I want. Okay, so let's try to do that. I'll just remove it from here. We'll only keep the variable and instead of returning the object, I will return new calculator. Okay, but now again we have the same problem. It's not a single instance because when the first time this get instance is called, we will return a new object. And again, when it is called the second time, again we'll return a new object. Okay, and I can prove it to you. See, again we are getting two different outputs. Okay, so what to do? So the solution is that maybe I can add a null check over here. Okay, I can simply say that if the object is null, then it means that the object has not been created yet. Okay, so in that case, I will simply create the object. Alright, and if it is not null, then I will just simply return my object. Okay, so this is how I will change my code. I'll repeat again. Basically, if my object is null, this means that the single object has not been created yet. So it will just simply create it. And the next time when the get instance will be called, that time this condition will be bypassed and we will reach over here and that object will be returned. Okay, so let me do one thing. I'll simply add a print statement here so that we get to know whether the instance has been created or not. Okay, so I'll just run the code and great. You will see that instance created has been printed only once, and again the output is same for both the objects because in reality they are the same object. Okay, so this is a better solution and this approach is called as lazy initialization approach because now we are only creating the object when this get instance is getting called. Okay, otherwise the object is not being created. Okay, it's just a reference variable and we will not, memory will not be wasted. Okay, now so far we have seen both eager and lazy initialization approaches, but everything we implemented till now was in a single threaded environment. So the question is, will our singleton still work properly in a multi-threaded application? Let's find out. So now what I'm gonna do is, I'll just simply remove this code for a while, and instead of a single threaded environment, now we'll create multiple threads. Okay, so I'll simply create a thread t1 equal to new thread, and inside this thread I will call calculator.getInstance. Okay, similarly I'll create another thread t2, and here as well we will fetch the instance. Okay, so if you don't know the syntax, it's no problem. We are just simply creating two threads. Okay, that's all you need to know. And these threads will execute when I'll call the method start. Okay, so I'll start t1 and I'll start t2. Okay, so at this point of time, at line number 23 and 24, these statements will get executed. Okay, and as you remember, we have a print statement over here. So this will let us know that in reality how many threads are created. Okay, so cool. I'll just run my application and great. You can see that two instances are created. So why did that happen? Basically what happens is that when multiple threads are executing, so when they are calling this method, it might be possible that two of the threads are actually analyzing this condition at the same time. Okay, so the thing is that both t1 and t2 are at line number 16, and at this point of time none of the thread has actually initialized the object. Okay, so for both the threads the object is null. That's why both of them come inside this if condition and both of them create their own instances. Okay, that's the problem. So whenever multiple threads will actually come over here at the same time, at exactly the same time, then multiple instances can still be created. Okay, so our singleton class basically fails. Alright, so somehow I need to make this class thread safe. So how can I do that? So see, if somehow I can make sure that whenever these threads are coming inside this method, they are coming here one by one. Okay, then my problem will be solved. Because if the first thread enters over here, it will create the instance, and then if the second thread analyzes the condition will fail and it will just return the object. Okay, like it was happening in a single threaded environment. Alright, so how can I do that? We have a very simple keyword for that, and that is synchronized. Okay, so synchronized is it is used exactly for this purpose, that it just actually acquires a lock on this method, and now multiple threads, if they are coming on this method, they will only enter it one by one. Okay, so let me run it now. Great. You can see that instance created has been printed only once. Okay, even if I run it again, if I run it multiple times, it will only be printed once. Alright, so this is how we can solve our problem using this keyword synchronized, and now our class is both singleton as well as thread safe. So the summary is, to solve the multi-threading issue, we can make the getInstance method synchronized. But this approach also comes with a drawback. With synchronized, only one thread can access the method at a time. Now that is good in the beginning because it will allow only one instance to be created. But once the object has been created, now there is no need for a lock because the if condition will always fail now. Even if multiple threads are there at the same time, still the if condition will fail because object has already been created. However, because of synchronized, even after the singleton object has been created, every thread still has to wait for the lock. Now this adds unnecessary overhead and can impact the performance, especially in high concurrency applications. So to avoid this, we use double checked locking mechanism. Okay, so let's see how it works. Basically the problem is that we have added the synchronized keyword at a method level. So even if the object has been created, still this method contains a lock. And ideally there should not have been a lock after the object creation. Why? Because after the object has been created, we need not to worry about whether multiple threads are accessing this line at the same time. Because in that case, the object is already not equal to null. So even if two threads are here at line number 16, for both of them, the object will not equal to null. And that is why for both of them, it will just bypass this and it will just reach over here. Okay, so we need to check the synchronized thing only once when initially the object is being created. After that, there is no need to check that. Okay, getting this point. Alright, so I'll just show you the correct solution and then you will get much more clarity on this. So what I'll do is I'll remove synchronized from here and we can just create a synchronized block. Okay, and inside this block, I will add this logic. Alright, and here we just write calculator.class. Okay, this is the syntax. Alright, so now what happened is that I have created a block and I'm saying that initially when two threads are coming at the same time, then we should have this synchronized because they should enter inside it one by one. Okay, but after the object has been created, then we should only check the condition that whether or not object is null. We should not check synchronized again. Okay, so for that, I will put another condition. If obj equal to null, then only check this synchronized. Otherwise, you can just simply return the object. Okay, let me explain. Let's say in the beginning, two threads are here at line number 16. Okay, at exactly the same time. So both of them will enter this if block because at that point of time, object has not been initialized and both the threads are coming at exactly the same point at the same time. So both of them will reach line number 70. Okay, now at this point of time, we have synchronized. So only one thread will enter this block and it will just, since the object will be null at that point of time, so it will create a new object. Okay, so the first instance has now been created. Now the second thread which was waiting here, it will enter, but this time the object has been created. So this condition will come in handy, and since object is not null, so that's why another object will not be created. Okay, so this is how both these threads will eventually the second thread will come over here and obj will be returned. Okay, so this is how the initial condition was handled. Okay, now after a certain time, the object has been created. Now if multiple threads are coming, so they will just reach line number 16 and this condition will fail. Okay, they will not even reach over here at any point of time because obj is not equal to null. Both these threads will eventually reach at line number 23 and the object will be returned. So synchronized won't be checked again ever again. Okay, that's my point. So that actually saves the time because the lock has not been acquired again and again. It was only acquired in the beginning when we wanted to create this object. After that, this lock was never acquired because this condition will come in handy. Okay. So this is how we actually implement the double log system. I will just run the code and we can just verify this. Okay, so we have two threads and I'll do t1.start and t2.start. Great. So only a single instance has been created. I'll run it again just to verify. Still only a single instance has been created. Okay. So this is how we can implement a singleton class in a multi-threaded environment. This is one of the best solution. Now let's look at some of the real world scenarios where singleton pattern is used. One of the example is logging system. Now in this, a single logger instance writes the logs throughout the application. Another example is database connection manager. In this as well, only one object manages the DB connections throughout your application. We can also use it for our configuration or properties manager. In this, the object reads the application once and then shares it everywhere in the application. Alright, now let's understand the last one, prototype design pattern. It is a design pattern that allows us to create new objects simply by copying the existing objects. See, sometimes object creation can be a very expensive operation. Maybe inside the constructor, we need to fetch some configurations from the DB or load some heavy files or maybe perform some other heavy setup. So if we keep creating the same object again and again using new, it can become very time consuming. So instead of creating objects from scratch every time, prototype design pattern allows us to create the object once and then simply clone it whenever we need another object. So this improves performance and saves time. Now in Java, this can be easily achieved using a copy constructor approach. In a copy constructor, we create a new object by copying the data of an existing object. And that's exactly what prototype pattern is. So let's implement this step by step and understand how it works. So I'll take a very real world example. You guys must have played some games in your mobile phones or in your computer. And in most of these games, you must have seen some bot characters. Like these are players only, but they don't do much and they kind of look alike. Okay, they look the same. So here prototype pattern works the best because prototype introduces cloning and we try to create the objects who are quite same. Okay, like with a little bit of differences maybe, but mostly they are same. So here prototype pattern works the best. Another examples could be like in those games we have trees that look alike or maybe some cars that look alike. Okay, so for them as well, we can use prototype design pattern. Alright, so what I've done is I've created a class gamebot characters and inside this class I have three fields, name, health and attack power. Okay, and we have a parameterized constructor. It takes three parameters and it initializes all the three fields. Okay, but before initialization, we are performing some expensive operations. Like maybe we are loading some character animations from the database or some sound effects, or we are preparing some AI file. Okay, so consider them as expensive operations, and that is why I have also added a thread.sleep. Okay, so we'll be waiting for 2 seconds because these operations take time. Okay, so this constructor is basically an expensive operation and it is very heavy to create an object for this gamebot character. Alright, apart from this, I also have a toString method so that whenever we print this object, we get to know what exactly the values are. Alright, so in the main class, I have created 5 different objects and as you can see, all of them's health is 100 and attack power is 0, but they have different names. Okay, we have bot 1, bot 2, similarly 3, 4, 5. Alright, so I have logged the start time, the end time, and in the end, we are actually analyzing how much time did this process take. Okay, so let me just add a logger properly. Total time taken. Okay, something like this. Alright, what's the problem? Maybe. Alright, cool. So let me just run it. So as you can see, it is taking some time. We are loading things for every object and eventually it finishes and you will see that the total time that it took was 10021 milliseconds. Okay, so basically around 10 seconds. Okay, more than 10 seconds. Alright, and this is actually very huge because imagine that there are hundreds, thousands of bots. So the application will take so much time to start. Okay, the game itself will take so much time to start. All right. So that's why we need a prototype design pattern. We somehow only want to create one object and rest of the objects can be cloned. Okay. So for that, the first thing that we do is that we will introduce a copy constructor. Okay. So let me show you how I write this. Basically, I'll create one more constructor, gamebot characters, and instead of taking all the parameters, I will take a reference of gamebot character only. Okay, I will take a reference. Let me call it GBC maybe. Okay, and using this, I will initialize the fields. Okay, so I'll just copy this part and I can say this gbc.name, similarly gbc.health and gbc.attackPower. Okay, so this is a copy constructor. And let me just make it private. I don't want to call it from outside. All right. Now what else we need to do? I will create an interface and let me call it clonable. Okay. So actually in Java, we do have a clonable interface itself. We can use that as well. But here I'm going to create my own and I'll show you how it works. Okay. So it will have a method void clone. All right. That's it. This is the only purpose. It has one abstract method, which is void clone. Okay. And we will make our gamebot characters class to implement this interface. So this implements clonable. Okay. Yeah. So now we will have to override this method. Correct. So I'll just say, okay. No, it is giving some other issue, but yeah, I will just override the method. So generate override methods and I will override clonable. Great. Okay, so this is an issue in void clashes with clone. Okay. All right. So this exact method is in object class as well. I'll name it something else. I'll say customized clone. Okay. We are creating a customized method for ourselves. All right. So similarly in this class, I will say customized clone. Cool. So again, I'll repeat, we have an interface clonable, which has only one method that we'll use to clone our object. So I've named it as customized clonable. So because actually in the object class, which was the parent class of all the classes, there also we had a clone method. Okay, so it was clashing with that. That's why I've changed the name. All right, cool. So here we only need to do one thing. We can just create an object by calling this constructor. Okay, so I will say that new gamebot character. Okay, gamebot characters, and here I will pass this. All right, why? I'll tell you, but for now you should know that here we will have to pass this. Okay, and it will actually not return void, it will return the object. Okay, return new gamebot characters. Okay, I'll change it here as well. This will be gamebot characters. And I can just actually make it generic. So let me not hard code it so that we can use this interface again as well. So I'll just make it T like this. I'll pass the generics over here and we can say that it implements clonable of gamebot characters. All right, like this. Cool. So this is how I will override this. I've called this copy constructor in this clone method and I've passed this reference. All right, now I'll explain why I've passed this. But as of now, you should know that we have a copy constructor and we have overridden this clone method. Okay, so let me make some changes over here and then you'll get to know why we passed this keyword. So I'll, instead of writing new again, for the first object, we have to write the new. But after that, what I can do is using this gbc1, I will call the clone method dot customize clone. Now, why can I call this method? Because this object is of the class gamebot characters and this method is present inside gamebot characters. Okay, that's why I can call this method using the gbc1 object. Okay, now what it does is it will call this constructor gamebot characters. So first thing is that this heavy constructor is not called. Okay, so this time heavy operations will not take place. And why have I passed this? Now this refers to the current object. Okay, now what is a current object? basically the object who is calling this method. Okay, so customized clone was called by gbc1. So here this is actually gbc1. Okay, so we pass gbc1 over here, and using that, it has its name, health and attack power. It copies it into the name, health and attack power of the new object that we are trying to make. Getting it? I'll repeat. We have gbc1 whom we populated over here. Okay, we gave a name, we gave some health and some attack power. Now using this object, I'm calling customized clone and I'm passing this. This refers to gbc1 because customized clone was called by gbc1. Okay, so gbc1 is passed here, and it has all these values, name, health and attack power, which now it is copying into the new object that we are trying to create. Okay, so this is how it works. So it actually will return that new object, and that will be passed here in the gbc2. Okay, and the thing that we need to note is that this constructor, which was the heavy one, it was never called. Okay, but basically it was called once, but after that it will not be called. Alright, so similarly I'll make the changes everywhere. I can say gbc1.customizeClone. Similarly here as well it is like this, and here as well I will make the change. Okay, cool. So now if I run my application, great, we only load these things once, and after that you will see that it only takes 2005, which means more than 2 seconds, but earlier it was taking more than 10 seconds. Alright, so you can see how much time has been dropped and how much performance has been improved just by introducing the prototype design pattern. Correct. Now you might be wondering one thing, that earlier when we created the objects, they all had different names, right? Like all were bot1, bot2, bot3, but now we have cloned these objects. So won't every name be bot1? Let's find out. Let me just print all the objects. Okay, so we print gbc1. Similarly, I'll just copy this. Alright, gbc2, gbc3, gbc4 and gbc5. Okay, let me run it. Yes, so as we can see that all the characters are named as bot1. Now see, I told you that yes, these bots look the same, but let's say still I want to give them different names. Okay, it might not be necessary that we want the exact object every time. So there should be a way that prototype design pattern handles that as well. Okay, we are introducing cloning, but we should still be able to change these values. Alright, so always what you should do is that in your class, you should always have the setter methods as well. Alright, so I'll just create these setter methods, generate setter for all the fields. Okay, now because of these setter methods, now I can change the values if I want to. Okay, so initially I will clone the object, that is fine. I have created this gbc2 exactly the same as gbc1, but even if I want to customize it a little bit, that I must do. Okay, so after this gbc2 was created, I will say gbc2.setName, and this will be actually bot2, and I'll just copy this. Okay, this will be gbc3 and bot3. Similarly, we'll have bot4 for gbc4, and again this will be 5 for gbc5. Okay, so we are allowed to change these objects even though we are cloning them in the beginning. Alright, so now if I run it again, great, you see we have different bots 1, 2, 3, 4, 5, and still the time is around 2 seconds only. Okay, so there is not much change in the time because changing these fields like this does not take much time. The only heavy operation was when we are creating the first object, because this constructor is heavy. Okay, that's the problem. So that is why we have to introduce a prototype design pattern in such cases. Okay, now obviously if the objects are totally different, then it does not work. Okay, because then it would be very tedious to do it like this, that we are cloning the objects and they are totally different from each other. So you will anyway have to set all the values. Okay, as of now there are only 3 fields, but let's say there are many fields and all of those are different. So then it does not make any sense and we won't be using the prototype pattern there. But as I said that I created a class for bots and they kind of look same. So I've taken health as 100 for each of them and they have no attack power. Okay, so that is why I could do this kind of thing. Alright, now we have understood the prototype pattern, but there is still one more important concept which we need to understand: shallow copy and deep copy. In a shallow copy, immutable fields like string or int, they are copied normally. But mutable objects are still shared between the original and the copied object. Meaning that if I'll change the value for a mutable field in one of the object, it will change for others as well. Okay, whereas in a deep copy, even the mutable objects are copied separately. So changes in one object do not affect the other. So far, whatever cloning we have implemented was actually a shallow copy and we were working with primitive types. Okay, we were working with immutable fields basically. So it worked fine. But our design will be problematic if I'll add mutable fields to my class. Okay, so let's see how, and let's understand how we can actually fix it using the deep copy approach. So as of now in this class, we only have immutable fields like string or int. But let's say I add a mutable field. Okay, maybe a list of string maybe, and let's say I want to add the weapons for these characters. Okay, weapons. So this is a mutable field. Why? Because list is mutable. By mutable I mean that it can be changed. Basically, wherever this list is pointing towards in the memory, if I'll make changes there, then it will be changed for all the objects. Okay, so let me show you what exactly I mean by that. Let's say we have a list of string here, weapons. Okay, and similarly I add it here as well. This dot weapons is equal to weapons, and in the private construct, in this copy constructor as well, I would say this dot weapons is equal to gbc dot weapons. Okay, so I've initialized it in the normal constructor as well as in the copy constructor. Okay, like this. And let me also add it in toString so that when we print the object we could just see it. So this could be weapons is equal to weapons. Alright, so I have added one more field now, and in the main class when I'm creating the first object, here I will have to specify this. Okay, so let's say I only add one weapon which is a normal rifle. Okay, new array list arrays dot as list. Cool. Okay, if I run my project, great. So we got this weapons, and in every bot the weapon is rifle. Okay, but now let's say for this GBC5, for this fifth bot, I want to add one more weapon. Okay, it's just that this bot is a little different and maybe I want to give one more weapon to this bot. So what can I do? I will just simply say that gbc5 dot, maybe first let me add some getter methods there as well. Okay, let me demonstrate this to you properly. We have getter methods, so all these methods. Okay, and I'm saying that let me fetch the weapons for this. Okay, so this I will extract in some variable. Okay, weapons. In this weapons I will add one more weapon. Maybe I add, let's say, sniper. Okay, now if I just run my project, great, you see that I made the change only in the bot number 5, but this sniper was added in all the bots. Okay, so this is what the problem is with this shallow copy approach. Basically what happened was that what we have done is we are directly copying this. When we created a clone, this was the original object, and from this original object we are directly copying it and passing it over here. Now this is a mutable field, so it means that it was, you can imagine that it is present in the memory, in the heap memory, and now this in every object this weapon is pointing towards the same location. Okay, so they are not created differently in memory. Every of the object has the same weapons only. Okay, there is only one object for weapons, basically a single defined space for weapon, and in all these objects the reference variables are pointing at the same point. So if I'll make a change in any one of them, then it will be changed for all the bots, and that's not right. Okay, it should not happen like that. So to solve this, we don't do a shallow copy. Okay, this is kind of a shallow copy that we are just directly copying it. Instead, what we do, it's actually very simple. We will create one more list. I'll say that this dot weapons, this belongs to a different list. Okay, so this time I have created a separate memory location for these weapons, and I'm saying that in that memory you just take this value. Okay, so now it is actually deep copy. What I mean by that is that now whenever we'll create a clone, every time a new memory location will be located for these weapons. Okay, and in that memory location, the value for the weapons will be this only. Okay, which whatever is of the original character. So initially when we will create the objects like this, so initially whenever we'll clone for every object, the value for the weapons will only be rifle, because we have specifically set it over here. Okay, we are saying that in the new list as well, keep the value as whatever the value is for the original object. Okay, keep it like that. So that is fine. But the memory location is different, because we have specifically said that it is a new array list. So this time when I will make changes in one of the object, like here we have made the change in this GBC5. So this change will not be reflected for other objects. Okay, you can see that all these have different memory locations for this weapon. That is why they are unaffected by the change in this fifth bot. Okay, so that's what you need to make sure, that whenever there is a mutable object, then you have to initialize it like this, that create a new object for this, like I created a new list for this, and just copy the value. That is fine. We need the original value, and maybe if we want to change it later, we can, like we did for the fifth bot. But don't make it as the exact object. Okay, don't copy the exact object if it is a mutable field like this. For int it is fine, because when we are copying int or string, then these are immutable objects. So even though we are copying the values, we are copying the object, they are creating a separate memory space. Okay, already it's taken care of. But it's not the case in case of a list, because it was a mutable object. Okay, so please make sure about this. And with this, I conclude this prototype design pattern. This was all about it. Today's topic of discussion is structural design patterns. These are the design patterns that deal with how classes and objects should be organized to form larger structures. In simple words, they help us decide how different classes should be connected together and how objects should interact with each other, so that the system becomes flexible and easy to extend. In this video, I'll cover three main structural patterns: adapter pattern, decorator pattern, and proxy pattern. Each pattern solves a different problem related to object structure and communication. So let's start with the very first one, adapter pattern. So what exactly is adapter pattern? It is a structural design pattern that allows two incompatible systems or interfaces to work together. Now, before understanding this technically, let's first understand it using a real-world example. Suppose you have a Type-C charger, but your laptop supports a different type of port. Now directly both of them are incompatible. You cannot connect them together. So what do we use? We use an adapter. The adapter sits in between and converts one interface into another so that both systems can communicate properly. And this is exactly what happens in software systems as well. In adapter patterns, we have three main things. First is the client. This is our main application that demands some action to be done. Second is the target class. This is the interface or class which provides the format that our client expects. And third are the third-party classes or libraries whom we want to use internally to actually perform the task. Now, it might be possible that these libraries and the target class have different formats, like different method names or different return types or different parameters. And since they are external classes, you cannot change their code. So the client and the third-party system becomes incompatible with each other. And this is where the adapter pattern comes in. The adapter sits in between them and converts the third-party system into the format that our client understands. Now, this was just an overview. Let's look at some real code and try to understand how this actually works. So I have created two different classes for payment. We have a payment service and a PayPal gateway. In the payment service, I have this method public string pay. It takes two parameters, int amount and int customer ID, and the return type is string. Whereas in the PayPal gateway, we have a method do transaction. Okay, so it's a different method which takes a double amount and an int CID. So CID is customer ID only, but its field name is different. Okay, then this PayPal have their own payment logic, and in the end it returns 1. So 1 means that the payment is successful. Okay, because we have an int return type. Okay, so that's why they are sending us 1 to tell us that the payment is successful. Okay, we have one more class, payment client. Now this class only talks to the payment service. Alright, so what it means is that you can consider it like this, that we have a client and payment service is like kind of a target class, and PayPal gateway is kind of like a third party library or third party class that we just want to call internally. Okay, but the client will not talk to this class directly. Alright, that's the case. So here in the client you can see that it's calling the pay method of this payment service. It is passing the fields as int only, and it is expecting a string result. Okay, so the format for client is fixed now. But the thing is, that we already have a PayPal gateway. It's kind of a third party library whose job is to perform the payment. So internally we want to use this. Okay, that's the problem now. So from here, from this payment service, we somehow want to use the PayPal gateway. But as you can see, both these classes are incompatible because it is kind of a different method whose return type is different, the parameters are different, and PayPal gateway has a different return type and a different parameter. Okay, so this is where generally we use the adapter pattern. Alright, but what I'll do is, initially I'll not use the adapter pattern. I'll show you that how we can perform the same thing without it, and then we'll see that what problem it causes, and eventually we'll move to the adapter pattern. Okay, cool. So what I can do is, somehow I can try to integrate both these incompatible classes. Okay, so for that, maybe I can take the field here, PayPal gateway. Basically, I am just trying to create an object directly in this class. Okay, and using this, I can just simply call PayPal gateway dot do transaction. I'll pass the amount and I'll pass the customer ID. Alright, now the amount is in int, but here we need it in double. So I will just call double dot value of. Okay, I will have to convert the amount. Cool. And also we want to return the result in like string. So I'll not hardcode success this time. I'll first say that whether this method, whether it is returning a value, let's say int result. Okay, so I know that if the result is equal to 1, then we are gonna return success. Okay, otherwise we can just say return maybe failed. Cool. So this is how my method will be implemented now. Okay, we have somehow integrated this payment service with this PayPal gateway directly. Okay, and as you can see that there is no problem in this as of now. This payment client is expecting to call this pay method, and it is still returning string only. Okay, and they have to pass int value only, and we have converted them over here. So we have somehow handled it internally. Okay, let me just run it as well. Great. As you can see, payment done successfully has been printed. Why? Because the result was 1. Okay, in this PayPal gateway, I've hard coded that it will always return 1. Okay, just for the sake of simplicity. And since result was 1, we returned success. And since the success was returned, so payment done successfully was printed. Okay, cool. But now the problem is, let's say that instead of PayPal gateway, now we try to use some more third-party library. Okay, I'll create one more class. I'll just copy this. Let me paste. Okay, no, I'll just skip again with the different name. Maybe this is Razorpay gateway. Okay, Razorpay gateway. All right, and they have another method. Maybe let's call it perform transaction, and maybe it is Boolean, and it also takes a double amount, and maybe this also they take as double. Okay, let me just change it, and this is Razorpay's logic, and instead of 1 they will return true. Okay, so now we have a Razorpay gateway, And in the future, if we decide that we want to change the logic here in this client, basically the client wants to call Razorpay gateway now. Internally, basically your application wants to talk to Razorpay gateway. Okay, so here we will have to make changes in the payment service. Correct. Now you can see that this code is already tested. This code already works with the client, and this Razorpay gateway and PayPal gateway, they also are external libraries who are like tested individually. Okay, they must have also been tested. That's why we are trying to just integrate with them. But in this approach, what we are gonna do, instead of writing it like this, I will have to actually take this Razorpay gateway, like this Razorpay gateway, and I will have to integrate this Razorpay gateway over here. Instead of all this logic, I will write the logic for Razorpay gateway, and eventually I will have to test it again. Okay, because this class has been changed, so we will have to test it again, and client is calling this class, so we will have to test the whole flow again. Okay, which is not very wise, and we are kind of changing the code in this payment service, and we are kind of repeating the things. Okay, so it should not be like that. It should be kind of a plug and play thing, that if we want to add a new library, we should not hard code it with this payment service. There should be no tight coupling, which we have over here. So what do we do? So for that, we use the adapter pattern, so that there is no hard coupling of payment service with any of these classes. We don't have to make any change in the payment service. All we need to do is that somehow we need to create another adapter for another third-party class. Okay, and that should work fine. Cool. So let me do that. What I'm gonna do, I'll not add any logic over here. Okay, let me just remove this and this. We will just keep this class as abstract. Okay, we will not have any logic. So let me just make it an interface, and I'm gonna say that string pay like this. Let's just leave it like this. Cool. And I will make, now this payment service is the target interface whom the client wants to talk to. So now it cannot have it like this. Okay, I'll make the change over here. And what we need to do is, I'll create different adapters for PayPal gateway as well as for Razorpay gateway, and we'll make those adapters implement this interface. Okay, let me show you how. I'll create a Java class, let's say PayPal adapter. Okay, and I'll make it implement this method payment service. Okay, so since this PayPal adapter, this adapter class implements this payment service, so they will have to override this method pay, and eventually the format will remain correct. Okay, so this format client needs, and since the PayPal adapter is implementing the interface, so client will get what they want in the correct format. Now all we need to do is, we need to have a reference of PayPal over here, and this will work. Okay, so instead of directly having the reference in the payment service, I just made it as an interface. I created a class adapter, which will be kind of an adapter for this gateway, and here I will have the reference. Okay, like this. And let me just initialize it using a constructor. Okay, I'll create a constructor. All right, like this. Cool. And here, now using this, we will add the same logic, that PayPal gateway dot do transaction. Now here we will perform all the conversion and everything. Okay, so double dot value of amount, and this will be customer ID. All right, let me just add it in some variable. Let me call it result, and if this result is equal to 1, we are gonna return success. Okay, otherwise return failed. Cool. So now I have implemented the same logic in this PayPal adapter instead of the payment service class. Okay, I've made this class as abstract. I've made it an interface, and we have one of the implementations is PayPal adapter. Now let's say we want to integrate Razorpay. So for that, I will create one more class, which will be a Razorpay adapter. Simple. So this is how we can plug and play any kind of library we want to in the future. We just have to create an adapter for them, and we have to make that adapter implement the payment service interface. Okay, we don't need to change anything over here, and we don't need to change anything in the client. So client get what they want in the correct format. All we need to do is we keep on needing to add child classes, and these will be adapter classes, so they will have like reference of their respective third party library which we want to integrate. So like Razorpay adapter will have a reference of Razorpay gateway. Okay, Razorpay gateway, and this will be this dot Razorpay gateway is equal to, let me change it here as well. All right, Razorpay gateway. Great. So Razorpay adapter implements the payment service, and this has the reference of Razorpay gateway because it is an adapter of Razorpay. Okay, cool. And here, instead of calling this using PayPal gateway, I will call it using Razorpay gateway, and it is not do transaction. The method is different. This is perform transaction. So here we will have perform transaction, and customer ID is also double in this case. So I will take double dot value of. Okay, generally we don't have customer ID as double. Okay, don't get confused, but just for the sake of example, I have taken it like this. And this perform transaction does not return int, it returns boolean. So this will be a boolean result, and I'll say if result is true, basically then return success, otherwise return failed. Alright, so this is how I made the change in a different class now, and now I only need to test the Razorpay adapter. Okay, that is fine. We are adding a different class, we have to test it, that is okay. It is kind of following the open close principle, but we did not modify the same class. Okay, we did not modify the payment service, and the thing is that if we are adding a new functionality, we have to test it. That is fine, but we don't have to change the existing code and don't have to test that part again. Okay, so now this is the adapter pattern. Let me just run it again. Okay, we have to make a few changes in the main as well, in the payment client as well. Actually, it was not properly written before. So here also I will add a constructor, generate a constructor for payment service. Okay, so we have to specify which particular instance of payment service we are taking, because obviously at a single point of time you will be integrated with only one of the implementation, right? It's not like that you are making a payment with Razorpay gateway as well as with PayPal gateway. At one single point of time you are using one of the classes, and we have adapters for every classes. So it's like just specify the adapter, and we'll adapt to that particular third party library. Okay, this is how this whole design works. So that's what we are going to do. In the main, I have actually created an object of payment client, and we call this method. So here now I will specify which particular adapter I want. So let's say I want the Razorpay adapter, and in this adapter we have to give the Razorpay gateway object. Okay, so like this, and this actually I'll tell you why I have taken it as a constructor. I could have written it directly like Razorpay gateway is equal to new Razorpay gateway. I could have done it like this also, right? Because Razorpay adapter always have this particular gateway only. But maybe sometimes the third party libraries are also abstract. Maybe this class, instead of it like a class, it would have been an interface, and this Razorpay gateway would also might have had multiple implementations. Okay, so that's why I've taken it as a constructor, so that we have the flexibility that maybe if a library is having multiple implementation, so we could have passed a particular implementation of that interface. Okay, getting this point? Cool. So I will just call it, so we have taken a Razorpay adapter, and inside we have passed the Razorpay gateway, and we are calling it like this. Now let me just run it. Great, payment done successfully. Okay, so at the client side, this is what is happening. It takes the payment service payment. Now this payment service was actually a Razorpay adapter. So actually when we call this method, the Razorpay adapter was called, and in the Razorpay adapter the perform transaction was called. So all the conversion have been done over here. It returned a boolean result. If the result is equal to true, we return success. So since we returned success, so in this payment client, this value was if result equal to success. That's why we will print payment done successfully. Okay, so that's why we got this printed over here. Okay, this is how it works. Similarly, I could have changed this to maybe PayPal adapter. and here I cannot pass Razorpay, so I will have to pass new PayPal gateway. Okay, and let me run it. Great. Again, payment done successfully. So the client side only this logger will be printed. Cool. So this is how our adapter pattern works. And I'll again actually specify you, I'll again try to explain the same point. I think that one more explanation would be good. So the point was that maybe this adapter, this PayPal adapter, as you can see that it is dependent on the PayPal gateway. So what I'm saying is that maybe this PayPal gateway would also be an interface and it might have multiple child implementations. So that's why we have taken this constructor, and that's why in the main class here we are passing new PayPal gateway. Because let's say if it has 3 different child implementations, then here we will have to pass one of those implementations. Okay, that's what I was trying to say. Alright, now let's look into decorator pattern. So what exactly is decorator pattern? It is a structural design pattern that allows us to add new behavior or features to an object dynamically. Now it may sound a little confusing initially, so let's understand it with a very simple real life example. Imagine you own a pizza shop. A customer starts with a basic pizza, but then they say add extra cheese, add mushrooms, add olives. Now think about it. One customer may only want cheese. Another may want cheese and mushrooms. Someone else may want mushrooms and olives. Another customer may want cheese, olives and mushrooms all together. So if we start creating separate classes for every possible combination, the number of classes will keep increasing continuously. And that becomes very difficult to manage. Instead, what if we could simply take the existing pizza object and dynamically add toppings on top of it whenever needed? That is exactly what the decorator pattern is. It allows us to wrap an existing object and keep adding new features or behavior dynamically at runtime. So in this video, we'll implement this pattern properly with 2 real life examples. First, I'll start with the pizza example, and then later I'll take another example where we'll implement a hotel room architecture. Now, a lot of people think that decorator pattern adds unnecessary complexity. So after I'll implement the design, I'll clearly explain why using the decorator pattern is much better than creating multiple classes for every possible combination. Cool. So let's get started. So I have an interface pizza which has 2 methods, get description and get cost. Here we describe what exactly the pizza is, and get cost will be used to fetch the cost for that pizza. Okay. Now let me start by implementing the most basic pizza. What I'll do is I'll just simply create a class, and let's say I can call it Margarita pizza. Okay. It will be the most basic pizza that we'll implement. And for that, I will have to make this class implement the pizza interface. Okay. So since we implement pizza, therefore we will have to override these methods. And in the get description, I can say maybe Margarita pizza. And the cost can be 200. Alright. So this is how we can define a simple implementation for this interface. Okay. Now let's say I want to add cheese in my pizza. So should I create another class for that? Should I create a separate class cheese pizza? No. Let's not do that, and let's try a different approach. What I'm going to do is, instead of creating separate classes for every different type of combination, I'll simply create a class for decorator. Okay, so let me show you how. I'll create a class, let me call it pizza decorator, and I'll make this class implement the pizza. Alright, so this is the first thing that we need to remember, that the decorator class will have an is-a relationship with the interface. Basically, it is a child of this pizza interface. So that is why we made it implement pizza. Okay, so since it's a child, that's why we will have to implement these methods. Okay, but I'll not do that right now. What I'm going to do is, I'll do one more thing. Instead of just making it like a child, I will also create a reference of pizza. Okay, so that is the beauty of this approach. What you need to remember is that this decorator class will have an is-a relationship with pizza, and it will also have a has-a relationship with pizza. Okay, it means that it is a child of pizza and it has a reference of pizza. Okay, both in the same class. Now, why are we doing this? You'll get to know in a while. But as of now, this is something that you should remember by heart. Okay, that is the main main catch for the decorator pattern, that this decorator will have an is a relationship as well as a has a relationship. Okay, now we are getting this error that we have to implement the method. So what I'm going to do is, I'll not implement the methods in this class. Instead, I will just make this class as abstract. Okay, so now when I make this class abstract, now it's the responsibility for the child classes to implement these methods. Okay, basically I'll be making more child classes of these decorator and they will be implementing the methods. Okay, so let's do that. First, I'll create a child class and I can call it cheese decorator. Alright, and this extends this class pizza decorator. Cool. Now since it is a child class of pizza decorator and here we have not implemented the methods, so this is where the responsibility comes to, and here we will have to implement both these methods. Okay, like this. Now this is where this pizza reference will come into use. I'll show you how. What I'm going to do is, instead of returning this, I'll simply say pizza dot get description and I'll add, let's say, cheese. Okay, like this. Similarly here I will say pizza dot get cost and maybe I add the cost as 50 more. Alright, now what just happened? Basically this pizza decorator has a reference of pizza. Okay, and since this cheese decorator is a child class of pizza decorator, so it can also use this reference. Okay, because it has inherited this from the parent, which is price decorator. Okay, so now using this, I call the get description method because in the pizza interface, we have the get description method. Correct. Similarly, we also have the get cost method. So that also I have called over here. Alright. Now, what exactly this will return? Let's not think about that right now. When I'll create the objects, you'll have a much more clarity. But let's say whatever it returns, we are just going to add cheese to it. Okay, this is how you have to think. The class cheese decorator is saying that whatever the current pizza will return, we will just add cheese to it. Similarly, whatever the current pizza's cost will be, we will just add 50 to it. Okay, think of it like this. Cool. And you know why we are able to use this pizza reference? Because this pizza reference is part of pizza decorator and a child can always use the parent's reference, basically parent's variables. Alright, this much is clear. Cool. Now let's move ahead and I'll create one more class and this time I can call it mushroom decorator. Okay, mushroom decorator. Cool. Again, this class also extends pizza decorator, so it can also use the pizza reference. And here instead of cheese, I'll say we add mushroom. Okay, and maybe the cost is 80. Cool. And similarly, let's create one more class. This will be olives decorator. Great. And this time we are adding olives. Okay, maybe the price is 100. Cool. So what happened is that we have created 3 different decorators. All of them are extending this pizza decorator class, and pizza decorator has a reference of pizza. That's why using that reference, we are just calling the get description and we are adding the respective thing which we want to add. Okay, and here we are adding the respective cost which we want to add. Okay, now the structure is ready and I'll start creating the objects so everything will be crystal clear. Okay, so what we can do is, first thing is, okay, let me just do one more thing first. In all these classes, in all these decorator, I will add a constructor. Okay, so let me start with this pizza decorator. So we have this field pizza. I'll just make a constructor. Okay, it will just make things easy. Cool. So for this field pizza, I have made this constructor. Okay, so whenever I'll create an object of pizza decorator, I will pass a pizza reference over here. Okay, and that will be populated in this pizza. Cool. Similarly here in the mushroom, here also I can just say generate a constructor, because you will see that it's giving me error. Okay, because in a child class we have to create a constructor. Alright, so I'll create it like this. So it's a constructor for mushroom decorator. It also takes a pizza reference and it's doing nothing complicated. It's just simply calling the parent constructor. Okay, by super we are just calling the parent constructor. So eventually this constructor will be called, which is present in the pizza decorator. Okay, so we'll repeat this thing for every class. In cheese decorator as well, I'll create a constructor like this. It will also call the pizza, the parent constructor. And similarly in olives also, I will create a constructor. Cool. Now, in the main class, I can just simply create a pizza object by saying pizza is equal to new margarita pizza. Alright. So far, I just created a simple basic pizza, which is the margarita pizza. Okay. So let me just call both these methods. I can say description and it will be pizza dot get description, and similarly I'll say cost. Let me just give some spaces. Okay, and this cost will be pizza dot get cost. Okay, so far we only have this margarita pizza. Let me just print this. Great. So the description is margarita pizza and the cost is 200. Okay. Now let's say I want to add cheese into my pizza. So will I be creating a different object? Like if I would have a different class for cheese pizza, then I would have created one more object, then maybe a cheese mushroom pizza. For that combination, I would have to create a third object. So I'll not do that. I'll use the same object and I'll just simply say that now this pizza is equal to new cheese decorator. Okay, I'll simply write it like this. And inside this cheese decorator, I can pass a pizza reference. Why? Because this pizza decorator contains a pizza reference. Okay, and this cheese decorator is a child class of pizza decorator. So here in the constructor, I can pass a pizza. And that's exactly what I'm gonna do. The pizza that we created so far, exactly this thing is I'm gonna pass over here like this. Cool. So what did we do? We have a pizza, which is a margarita pizza. And now I change this object. I'm trying to change this object as a new cheese decorator. So I'm making it as a cheese decorator's object. Okay. And why am I able to do this? Because this pizza is of this type pizza, and this cheese decorator is kind of a grandchild of pizza only. Okay. You see, this pizza decorator implements pizza and cheese decorator extends the pizza decorator. So we have a hierarchy. That's why this pizza reference can be created as a new cheese decorator as well. Okay, that's why we have a relationship. Getting it? That's why we made this decorator extend the pizza interface. Okay, and now here I could have passed pizza. Why? Because we can have it in a reference. So it will call this, and the pizza which we passed, which in this case was margarita so far. Okay, so here we pass the margarita and this dot pizza is equal to margarita. So now the object that we have created, which is this cheese decorator, it has the pizza reference as the margarita pizza. Okay, so now I'll just copy this and I'll paste it again. So again, after this pizza, when we have changed this pizza, we are calling pizza.getDescription. Okay, so what exactly should be called? Basically, it's a cheese decorator object, right? So this method should be called, correct? And in this method, we are saying pizza.getDescription. Now, which pizza is this? This is this reference. And this reference we populated in the constructor because we passed the margarita pizza over here just now. Right here, you can see we passed the margarita pizza. So this pizza reference we have already populated, and this is actually margarita. Okay. So when this get description is getting called, here this pizza is actually margarita. So pizza.getDescription will give us what exactly? It will give us margarita, that we have seen over here as well, that so far since the pizza was margarita. So here in the description we'll get margarita. And what we have done? We have just added cheese to that. Okay. So that is the decorator pattern. Exactly same thing is happening here as well in the get cost. This pizza is actually margarita pizza, and we will just fetch the cost for that margarita pizza and we'll add 50 to it. Okay. So let's just see. I have added the print statements again. Let me run it. Great. So initially it was margarita pizza and the cost was 200. Now it's margarita pizza cheese. Okay, I've added the colon. I'll just make it more clear. No colon. Okay, let me run it again. Great. So you can see the description is that it is a margarita pizza cheese and the cost is now 250. 200 for the base pizza and 50 for the cheese that we added. Cool. So you see how flexible it is. We just have to decorate our pizza. We can use the same object and we can keep on decorating it. Okay, so similarly, what I'll do, I'll just add pizza is equal to new, let's say mushroom decorator. Okay, again I'll pass the same reference. Now this time, this pizza, this is not an object of margarita. No, this time it has already become an object of cheese decorator. Okay, so when I pass it over here, again the constructor is called, and now this pizza reference is equal to the cheese decorator pizza. Okay, so when I'll call this description, when I'll call this pizza.getDescription, so this method will be called. The method inside mushroom decorator, this getDescription will be called. Okay, but this time this pizza is already a cheese decorator. So the description that will fetch will actually be of the cheese one. Okay, and what exactly was printed when we called for the cheese one? It was margarita plus cheese. So this time it should be margarita plus cheese plus mushroom. Okay, so let's see. Let me just run it again. Great. So this time the description is margarita, pizza, cheese and mushroom, and cost is 330 because in the 250 we added 80 more. Okay, so this is how it's working. I'll do the same for olives as well. Now the pizza is equal to new olives decorator, and again I'll pass the pizza. Alright, now this time the pizza is actually of the type mushroom decorator. So when I'll again call the get description, okay, here the reference will be actually mushroom decorator, and mushroom decorator dot get description returned all these three things: margarita, pizza, cheese and mushroom. So this time it will be olives will also be added to that. Okay, and 100 will be added to that cost. So let's just check. Great. So this time margarita, pizza, then cheese, then mushroom, then olives, and then cost is actually 430 because 100 was added to 330. Okay, so this is how we are adding one thing again and again as we want to do. Alright, so this is the best thing that you can do in a decorator pattern. You can make any type of combination. Okay, any type of combination. Like if I only wanted olives and cheese, let's say, so I could just remove this part. I don't need a mushroom in between, so I'll not take a mushroom. Let me just not print this as well. So I want a margarita pizza with cheese as well as with olives. Okay, so I'll just take these two, and great, this time it's a margarita pizza, cheese and olives. Okay, so you can take any combination now, whichever you want. So yes, we have different classes for olives, different classes for mushroom, different for cheese. So yes, in that way we have a few classes, but we don't have classes for every possible combination. Okay, if we were to make classes for every possible combination, that would have not been easy to manage. Okay, so yes, a little complexity has been added, but it's still very far less than what would have been if we would have made classes for every combination. Getting the point? Okay, because as of now we only have 3 different types of pizza. Let's say there are 10-20 types of classes like this, so we'll only need 10 or 20 classes, but if you count the combinations, they would be more than hundreds. Alright, so we just saw how the decorator pattern worked perfectly in the pizza example. Now let's move to another real life example, a hotel room booking system. Suppose a customer books a basic hotel room, but after booking they may request additional services like add breakfast, add Wi-Fi or add minibar access. Now again, different customers can choose different combinations. One customer may only want breakfast, another may want breakfast and Wi-Fi, someone else may want Wi-Fi and minibar, and another customer may want all the services together. So if we try to handle this by creating separate classes for every possible combination, the number of classes will grow rapidly and the design will become very difficult to maintain. Instead, we can simply start with a basic hotel room object and dynamically add extra services whenever needed. And that's exactly what we are gonna do. So this time I have taken an interface room. It also has a get description and a get cost. I have implemented the basic room. It overrides both these methods and it just returns that it is a basic hotel room and the cost is 3000. Okay, now let's say I simply want to include breakfast in my room. So for that, first I will just create a class maybe call it room decorator. Okay, room decorator. And as you know, we'll make this class as abstract, and simply it will just implement the room interface. Okay, and we will have a is a relationship, as well as I'll create a reference and we'll have a has a relationship. Okay, let me just create a constructor as well. Can simply add a constructor, generate constructor. Okay, now if I want to have a breakfast included, so for that I will create a class, maybe breakfast room. Okay, and this simply extends the room decorator. Okay, so this class will have to implement the methods, and that is what we are gonna do. Again, we can use this room reference because it's present in this room decorator. Using this reference, I will just simply call the description and I will just add that with breakfast. Okay, something like this. Cool. And I can just increase the charges. I will simply say room dot get description, and the charges have been increased by 500. Okay, simple. Okay, not room dot get description, room dot get cost. Cool. Again, let's just add a constructor over here. Great, and this will call the parent constructor. All right, so similarly we'll have other classes. Maybe I just need extra bedding, so for that we can say extra bedroom. Cool. And here I'll say with extra bed, and maybe the cost is 1000 more. All right, and we can have one more class. Similarly, let it be mini bar room, and this also extends the room decorator, and this time I'll say with mini bar. Great, and the cost is maybe 800. Cool. So again, I have created 3 different classes for 3 types of additional charges, and now I can just simply create the objects. First, I'll create an object of a basic room, so it will be room is equal to new basic room. Now in this room, I can just change it to, let's say I want to add extra bedding. Okay, or maybe I want to have a breakfast room first, so I'll say like this. I'll just pass this room only. Similarly, I can again room is equal to new. This time it is extra bedroom. Okay, so I'll again pass the room, and maybe I want to add a mini bar, so I will again pass the room reference. Okay, so first we have a basic room, then we pass that basic room in this breakfast room class, then here I pass a breakfast room in this extra bedroom, and here I pass the extra bedroom in this mini bar room. Okay, in the end, let me just print this system.out.print. So description, and this will be final room.get description. Okay, and similarly we can have a cost, and this will be simply room.get cost. Okay, I'll just run it. Great. So it is a basic hotel room with breakfast, with extra bed, and with minibar, and the total cost is 5300. So if you'll add all the cost, it will come out to be that. Okay, so let's try one thing. I'll just run this code in a debug mode so that we get a better idea of what exactly is happening inside all this. Okay, so let's do that. I'll just simply add the statement everywhere. We have it over here, then here, then again over here. Okay, so I'll put a debugger here and let's run it. Great. So as of now, we don't have anything. Now we have a room object. Okay, and eventually if I'll just move ahead, great. So you will see that this room has, if I move ahead, so this room.get cost, as you can see, if we'll just evaluate this, so this will be 3000 because it's a basic room. Okay, let me show you this as well. Evaluate, and it's a basic hotel room. All right, so this room we pass in this new breakfast room. I'll just go inside like this. Okay, so it calls the super. So I'll again go inside and I'll reach here. Okay, so at this point, this room is actually a basic room. So as I said, when we are trying to create an object for like in this case, we were trying to create it for the breakfast room. So in the reference, what we passed is actually a basic room. Okay. So this dot room equal to the basic room. All right. So we move ahead. At this point, basic room has been populated in that variable. So if I come over here, I'll just move ahead. Great. So if I just check room.get description over here, so this will be basic hotel room with the breakfast. Okay. Because this get description would have been called of which particular class, it would be the breakfast room. So in the breakfast room, this room was actually, if I just evaluate it, okay, this is actually basic hotel room. Okay. All right. So it has been now basic hotel room with this breakfast. Now the breakfast has been included. Okay. Similarly, if I just go over here in this extra bedroom, okay, I'll just go inside and again we'll go inside. So this time if we'll check, so you see this room now this time is actually the breakfast room. Okay, it is not the basic room now, and so that's why this room is populated as breakfast room. Okay, I'll move ahead. Great. Now we'll see after the print statement, if I again check these room.get description, as you can see, if I'll evaluate this, so it will be basic hotel room with breakfast with extra bed. Okay, because now extra bed has been added. All right, similarly, it will be for minibar. Again, I'll go inside this and here I will go inside this again. So now this room reference, this would be the extra bedroom. Okay, so room is now the extra bedroom. I just move ahead like this. And now after this, the room.get description has been called. So which means that at that point of time, basically minibar was also added. Okay, that's what happened. Cool. So this is how the decorator pattern works. It's actually very handy in a lot of cases. So it's a little bit confusing, but once you try to implement it yourself, you'll get a very good, grasp on this. Okay. Now let's understand the last one, proxy pattern. It is a structural design pattern that provides a placeholder for another object. Basically, instead of directly accessing the real object, the client talks to the proxy and the proxy controls how the real object is accessed. We mainly have three types of proxy patterns: virtual proxy, protection proxy, and remote proxy. So let's start understanding all three by coding some real life hands-on examples. In the first example, I have taken an interface named video which contains this method void play. So let me just start by implementing this interface. For that, I can simply create a class. Let's call it movies. So public class movies implements the video interface. Okay. Now inside this class, I can have my own fields. Maybe I add a field private string file name. All right. So this class can have a field of its own. And for this field, I will also create a constructor. Okay, generate a constructor. All right. Now, since this class is an implementation of video, so we will have to override the method. Okay, so we'll override this method play, and maybe I can just simply provide a logic here that video is playing. Okay, and we can print the file name. Cool. So far it's a very simple implementation. We have defined a class which implements this video interface. It has a field inside it. We have a constructor for that, and we have overridden the play method, and here we have some logic. Okay. Now what if I just simply add some expensive operation inside this constructor? Okay, let's say in this constructor we are performing some load video operation, and this is a very expensive operation. By expensive, I mean that it will take a lot of time. Okay, so now it's a bit problematic. First, let me just add a method for this. Maybe I can say load video, and I'll have a print statement loading video from server. Okay, and since it's an expensive operation, I'll just add thread.sleep just to demonstrate it. Okay, so this will require exception. Okay, I will add it here as well. All right. So now what we did was that inside this class, in this constructor, I'm saying that whenever we are just initializing this file name, After that, we also have to perform a load video operation. And this is a very expensive operation. It takes time. So now whenever we'll create an object of movies, it will take up a lot of time. Okay, so this is a kind of problem that I introduced. Okay, so let me just start by trying to make the objects and we'll see how we can solve that. Okay, so I'll simply say not movies, I can say video is equal to new movies. Okay, and here I can pass the file name. Alright, maybe Shawshank Redemption.mp4. Okay, and I'll add exception here as well. Cool, so this will be the video 1. Similarly, I'll create 2 more videos. Okay, video 2, let me just call it golmaal.mp4, and I have another movie. Okay, maybe prestige.mp4. Okay, this will be video 3. So I've created 3 video objects, basically 3 movies object, and in all these 3 you will see that this load video method will be called, okay, whenever we are creating their object. Alright, so let me just run it. Okay, so you see the print statement, then it waits for 4 seconds, then another print statement, and again after that it's loading video from server, and now eventually the process is finished. Okay, so you saw that in order to just create these objects, I had to wait for 4 seconds for every object. Okay, but the point is that I have not even played the movies yet. I have only created the object and still I have to wait a lot. So this is not a right design. We should have some kind of a lazy initialization where I have to load the movie once. Yes, I will have to load it, but only when I'm actually playing that movie. Because as of now, we have not called this method play, but still we have to wait. Okay, so in such cases, if our design is like that, then we can use the proxy design pattern. Okay, so what is our goal? We have to do a lazy initialization and we have to make sure that the loading part is done only once. Okay, it's not done every time when we are playing. It should be only be done once. Okay, so let's try that. Actually, it's a very simple design pattern. All you need to do is you need to create a proxy class like this. Now this is kind of a copy of this class. So what you're going to do, you will try to replace the steps. So it also implements the video. Okay, and here as well, we will have the file name. All right, and let me just create a constructor. Cool. So inside this constructor, I will not have the load video method. Okay, whenever I want to create an object of movie proxy, that will not be an expensive operation. Okay, so here I will not add the load video. That will be the only difference. And since I have this also implements video, so I will have to override this method play. Okay, now how does the pattern works? That I have implemented video, that is fine, but I will also create a reference of video. Okay, video like this, and using this I will just create the object inside this play method. So I'm saying video is equal to new movies. Alright, and here I can pass the file. So I'll pass the file name. Okay, let me just add the exception, change all the methods. Cool. And using this video, now I will call the play method. Okay, so what exactly is happening? I created a class movie proxy. This class also implements video. So I had to override this method play. But what I'm doing is that inside this play, I'm actually creating the object of movies only, okay, which was the real class. So I'm creating an object of it, and using that object, I'm calling the play method. Okay, so in reality, the play will be called for of this movies, okay, which we exactly wanted. Okay, but now see, the problem is that yes, I have added this logic inside this play method. So now we have achieved the lazy initialization, correct? But it will be called whenever play will be called, we'll be creating a new object every time. Okay, so is there some way that we can avoid that as well? So yes, it's actually very simple. I'll simply add that if video is null, then only we should have this logic. Okay, simple. Now we have a lazy initialization. Why is it lazy? Because this object creation part is not happening here in the constructor. Okay, it's happening whenever we want to play the movie actually. Okay, so this new movies object will only be created whenever this play will be called, and hence this load video will only be called whenever this play is called. Okay, and since we have this check, so only the first time this object will be created. For the rest of the time we will directly call the play. Okay, so what it means is that directly this method of movies will be called, okay, after the first time. Alright, so we kind of achieved both the things. Now all I need to do is I will just change it to movie proxy and movie proxy. And as you can see here also we have to pass the file name. Why? Because we created a variable file name in this movie proxy as well. Okay, so we kind of have to create a copy of that class, and eventually we are calling the method of this real class only, okay, which is the movie. But all we are doing is that we are not calling it inside the constructor, we are calling it in this method, and we are adding a null check so that it is called only once. Okay, that's the only change. Alright, so now if I run it, okay, let me just add a construct, add some print statement, okay, so that it's clear what exactly is happening. So I'll say proxy object created. Okay, now in the main class we have only created the objects, we have not called the play method yet. Okay, great. So you saw that this time we didn't have to wait, we only created the objects and they were created in real time. Why? Because in the constructor of movie proxy we don't have the load video method, we are only creating these objects. And now when I'll actually call the play method, okay, I'll call these play methods. Okay, now we will have to wait. Okay, so all three of the objects were created. Now the first video was loaded and then it was played. Similarly, second video was loaded and then it was played, and now third is getting loaded and again it is being played. Okay, so yes, definitely when we'll play these at one time we will have to wait, but if I play them again, let's say like this. Okay, so for the first time it's loading the video from the server, it's being played, then it's loading the second video, it was played again, now it's loading the third video, and after that it was played again. But after that again the videos were played instantly. Okay, we didn't have to wait. Why? Because after that when the second time this play was called, we had a null check in this movie proxy, and because of that null check it just skips this condition and it reaches over here and the video is played directly. Okay, the file is not loaded again. Alright, so this is how the proxy pattern works. Now one thing I want to clear over here is that of course you could have done it without proxy as well. Like what we could have done is I could have just added a flag over here, some boolean flag that says that has the object been created, and instead of writing this load video here, I could have added it here using that flag. Okay, I would have placed that condition of flag like this. I'll just show you how I can do that. So we have this boolean is object created, and I can say if it is created then I will not create it again. Okay, if it is not created then only we'll load the video. Okay, for the first time, something like this, and I would have just created the object at this point of time. Okay, something like this logic I could have added using this boolean flag. Okay, but my point is, see, design patterns are not about doing things like without them we cannot do things. Of course we'll have our workarounds and we'll be able to do things without design patterns as well. Okay, but this thing was only a workaround, it was not a good design, because you will have to define some documentation that why are we needing this flag, and literally there is no actual purpose of that flag in this movies class. Okay, so we are not following the single responsibility principle as well. We are doing everything in movies. Movies should be only about this play, it should not be about that condition that we were checking using that flag. Okay, so for that we should have a different class which is this movie proxy. So this is what proxy pattern is. It has a class, a separate class that calls the same method only, But if you want to customize that thing, if you want to add some condition, if you want to add some flag, any kind of thing, that you can do in this proxy class. So we have divided the responsibility, and that's why we are obeying the solid principle, the first principle of solid principle, which is the single responsibility principle. Now, so far, the design which we just saw was actually the virtual proxy design pattern. It allows us to delay the creation of a heavy object until it is actually needed. Now let's move on to another use case where we need a proxy. It is the protection proxy design pattern. It controls access to the real objects by performing some authorization or adding permission checks before allowing operations. So let's see how it works. In this example, I have taken an interface database which has this method void delete. We also have an implementation of this interface database, which is this class MySQL database. And as you can see, we have overridden this method and it is just saying that user has been deleted. Okay. Now, so far there is no protection in this design. Anybody can just simply create an object like this, database DB is equal to new MySQL database. And using this object, they can simply call this method. Okay, so anybody can call this method. Now, if I want to add some protection, for that, here I will be using a proxy. Okay, so I'll simply create a class database proxy, and this class will implement the database interface. Okay, and here also I will just have a reference of database as well. Okay, database DB. Cool. Now this time I will create a constructor. I'll just simply write it like this: public database proxy. And in this constructor, I will straight away initialize this DB. Okay, this .db is equal to new MySQL database. Alright, so why am I not doing lazy initialization this time? Because this MySQL database is not a heavy operation. Okay, it's a totally different example. So I just wanted to make that clear. Alright, so that's why here I can have a, in the proxy I can have a eager initialization as well. Okay, so I'm creating this object in the constructor itself. Okay, now what I'm saying is that since this class implements the database, so I will have to implement these methods. Okay, so we'll implement this method delete. Okay, so using this DB, I will call db.delete. Alright, so as of now, have I provided any protection? No, I have not done anything. I have simply created a DB reference in this database proxy. Here I created the object, and using the same object, I'm calling the delete method. Okay, so let's add some protection. What I can do is I can simply define a string role, and I can say that if role dot equals maybe admin, okay, then only we should be able to delete. Otherwise, we should simply say that maybe I can say that access has been denied. Okay, access has been denied. All right. So this is how I can add a protection in this database proxy class. And as I said in the previous example also, I told you the same thing, that we could have done it in this MySQL database as well, but we should have a single responsibility for everything. And the protection part I want to do using this class database proxy. Okay, so that's why I've created a separate class for that, just to obey the single responsibility principle. Okay, so here this time we are taken the reference of database and we have taken a string role. Using this role, we are adding some conditions, but inside we are doing the same thing. We are calling db.delete, and this delete is actually of this real class, which is this MySQL database. Okay, so I'll make a few changes in the main. Instead of directly creating MySQL database, I'll just simply create database proxy, and I will call it using this. Okay, and let me just actually add this field in the constructor. Okay, so this dot role is equal to role. All right, and now when I'll create an object of database proxy, here I will have to pass the role. Okay, so if I'll run it like this, great, user is deleted. But if the role is something else, maybe manager, great, now the access has been denied. All right, so this is how we can use a proxy pattern for protection as well. All we need to do is we need to define a separate class which also implements the main interface, and here we will have to have a reference of that interface. Okay, we can initialize the object in the constructor itself, but we can add some condition to call that method. So in this case, the condition has been added on the basis of role. Okay, now let's look at the last one, remote proxy pattern. A remote proxy design pattern provides a local representative for a class that exists on the remote server, thereby handling communication between the client and the remote class. Alright, let's understand this with an example. So I have created two different packages, one for the local server and one for the remote server. In the remote server, I have an interface named weather, which has this method getWeather. And we also have an implementation for this interface, which is this class weather service. Okay, so as you can see, it overrides the method and provides some implementation. Alright, now what I want is, I want to access these classes in this local server. Okay, so for that, I have created a class weather proxy. Okay, so I've already implemented the design over here. I'll just walk you through it and we'll try to understand how it works. Okay, so like we did in the earlier example, this weather proxy has to implement the weather interface, okay, which is the main interface, and it also has to have a reference of it. Now I'm initializing this reference inside the constructor. Here we are creating an object of weather service, and since it implements weather, so we will have to override the method getWeather. Okay, now here we have a few methods. I have authenticate, open connection, then serialize the request, and then in the end I'm sending the HTTP request. Okay, so I've created different methods for that. Here I'm authenticating, here I'm opening the connection, then serializing the request, and then in the end we are sending the HTTP request, and at this point of time we are actually calling the getWeather method, okay, using this weather object, which is actually the object of weather service, okay, the real class. Alright, so eventually this real method will be called, which is present in this class weather service, and this will be returned. Okay, now why have I created a proxy over here? Because see, we have a client which is basically this main class, and it want to somehow call the method of weather and weather service. Okay, it somehow wants to access this weather service, but before accessing we have to perform a certain steps. We have to authenticate the request, we have to open connection, serialize the request. Okay, so we have to perform some duties, and again I will have to obey the single responsibility principle. The thing is that all these operations should not be done inside the client. Okay, so we should not be directly accessing this weather service class. Thereby I introduced a middle layer here, and this is just performing all these duties, and then it will eventually call the method of this weather service. Okay, this is how it is working. So whenever we want to try to access some class which is on a remote server, there also we can use the weather proxy inside the local server. Okay, that's it. Today's topic of discussion is observer design pattern. It is a design pattern where one object automatically notifies multiple other objects whenever any change or any event occurs. Basically, there is one subject and multiple observers. Whenever something changes in the subject, all the observers are automatically notified. Let's consider my YouTube channel as an example. You can think of the curious coder as the subject and all of you subscribers as the observers. Now, whenever I upload a new video, the channel notifies all of its subscribers and they receive an update about the new content. This is exactly how observer pattern works. And speaking of notifications, if you haven't subscribed yet, do subscribe to the Curious Coder so you never miss any upcoming videos. Alright, with that being said, let's start with the implementation. So I'll start with the example. The first thing that I'll do is I'll simply create a class called YouTube subscriber. Now this class represents all the observers out there. Okay, and inside this class we can have a couple of fields, maybe private string name and private int id. Okay, so every YouTube subscriber will have a name and an id. Alright, and I can also add a constructor in this class for both these fields like this. Okay, so this is my observer class. Alright, now we should have one class for the subject as well. In my example, the subject will be my channel, right? So I'll create a class, the Curious Coder channel. Cool. So this is the subject and these are the observers. Okay, now my channel should have more than one subscriber. Okay, it should have multiple subscribers. Thereby I will develop a one-to-many relationship. So I'll take a list of YouTube subscriber like this. Let me just, okay, subscriber list is equal to new array list, and we'll just import this. All right. Okay, so this is the most basic design which we need for any observer pattern, that we need a subject and we need an observer, and both of them will have a one-to-many relationship. Okay, that's the first thing which is required. All right. Now in this class, I should have a few methods. Like I should have a method named subscribe. Okay, this method will be used whenever I want to add a subscriber. So I'll just simply take a YouTube subscriber like this, and we will just add it inside the list. Okay, dot add subscriber. Okay, now we can also have unsubscribe, but as of now I'll not implement that. Okay, we'll move ahead. So basically the observer pattern says that anytime any change or any event occurs, we should notify all the subscribers. Okay, that is what we want. So for that as well, I'll have a method. Okay, first let me make this one also public. Yeah, I have a method notify subscribers. Okay, and what exactly we'll do, we'll simply loop on this list and we'll notify all the subscribers. Okay, so I can just simply say that for every YouTube subscriber which is part of this list, we should just loop on them and we should notify. Okay, we should notify them. Now how will we notify? For that we should have a method in this YouTube subscriber, okay, which receives the notification, right? So generally we call that method as update. Okay, we call this method update, and here I can just simply say that system.out.print received notification. Okay, so in my example I was gonna say that whenever I upload a video, I want to send out a notification. So let me just say upload video received notification. Okay, something like that. All right, cool. So in this, the Curious Coder channel, I can just simply now take this subscriber and I can call this update method. Okay, so this is how we notify the subscribers. We have a list of subscribers in this channel. We just loop on them and we notify them one by one. Okay, simple. Now this method I can call whenever I want to notify. Now in my example, I want to notify my subscriber whenever I upload a new video. So I'll have another method for that. I can say public void upload video. Okay, and whenever the video is uploaded, I can just, let's say for now I simply have a print statement that say video has been uploaded, and after this video has been uploaded, I can call the method notify subscribers. Okay, that's it. So this is my basic observer pattern design. This is the most basic design. I'll definitely add more features to it. Okay, we'll improve it, we'll make it a little more generic, but this much what I've done so far is actually the observer pattern. Okay, so what all you need to remember: you should have a subject, you should have an observer, there should be a one-to-many relationship, and you should have a method to notify all the observers, where you loop on all the observers and one by one you notify them. And in order to notify them, you should have a method inside this observer class. Okay, this is the observer design pattern. Alright, so let me just run this much first. Let's say we create a few subscribers, new YouTube subscriber. Okay, so let me name them. Maybe name is Naman, ID 1. Similarly, I'll create 3-4 subscribers. Okay, we have subscriber 2, subscriber 3, subscriber 4. Okay, let me name it Harshit, ID is 2. We can have Manvi, ID as 3, and we can have Chahat, ID as 4. Okay, so we have 4 different subscribers. Now I want them to subscribe to my channel. So let me first create an object of my channel. The Curious Coder channel is equal to new the Curious Coder channel. Okay, and using them we can just call the subscribe method. Okay, and here I can add the subscriber. Okay, so using this object I called the subscribe method, and the subscriber which was added will be just the subscriber which we passed over here will be added to this list. Okay, cool. So similarly, I'll add other subscribers as well. We can have 4 statements: subscriber 2, subscriber 3, and subscriber 4. Okay, so we have completed the one-to-many mapping. Now all I need to do is I'll just simply call the method upload video, and you will see that. Great. So first the video was uploaded. Okay, here the video has been uploaded, and after that all the subscribers were notified. Okay, so we received 4 different notifications because all the subscribers were notified. Okay, like this. Cool. So we have understood the basic design. Now let me add a few things. Let's say I want to add a couple of fields in this class. Maybe I want a video title or a video file name. Okay, so whenever I upload a video, I want this information as well. Okay, so what I'll do, I'll just simply add these in this arguments in the upload video. Okay, we can have a string video title and a string video file name. Okay, so I'll take both these fields from the client. I'll pass it from here. Let's say my video is on observer patterns. Okay, so the title is observer pattern and the file name is observer.mp4. Okay, something like this. Cool. So I pass these values in this upload video method, and inside this method I can just simply set these fields. Okay, so this dot video title will be equal to video title, and this dot video file name will be equal to video file name. Okay, so I've populated both these fields inside this upload video method. All right, now let's say I want to pass these fields to the subscribers as well. Okay, I want to pass this information to the subscribers, that which video am I uploading and what is the file name. Okay, so how will I do that? It's simple. I have to make a few changes in this update method. So I have already populated these fields. I will just pass it over here. Okay, video title and video file name. All right, and in this update method I'll just make a few changes. I'll simply say string, let's call it title, and string file name. All right, and here we are kind of using these things. Okay, I'll just add them to the print statement. Maybe I can say uploaded video, and we have a title for this video, which will be my title. Similarly, we can have file name as well. All right, and this will be the file name. Okay, like this. And we can also use these name and ID. Okay, we can print here that which particular subscriber is receiving the notification. So I can add it here, plus received notification by, maybe I will add the name, and we will have a ID. Okay, so I have make use of every field. All right, so what we did was basically we passed this video title and video file from the client. Okay, we are passing this information, we are saving this information inside the subject. Okay, we have 2 fields for that, and we are passing both these fields in the update method. Okay, so that is what also have to be done whenever we want to send some kind of information to the subscriber. So in that case, our update method will have a few arguments. Okay, this is how we'll make a change in the design. Okay, that will add a few arguments. Okay, so now let me run it. Great. So again, video has been uploaded, and as you can see, we get these notification that upload video, the title is observer pattern, the file name is observer.mp4, and we are saying that received notification by Naman, Harshit, Manvi and Chahat. Okay, ID 1234. All right, so this is how our update method is implemented. Okay, now one thing is, let's say in this channel I have more fields. As of now, I only have a couple of fields, but let's say there is more data that I want to have here, and all that data I want to send in this update as well. Okay, maybe we could have some description of the video, some thumbnail, timestamp. Okay, there could be n number of things, and I want to send all these things to the subscriber. Okay, but you see how many arguments will we have? Okay, it will become very lengthy and it will not look very good that we are just keeping on adding the arguments as and when we get a new field. Okay, so a better way is that instead of passing all these arguments, what I do is I simply passed the reference of this object. Okay, I pass the whole curious coder channel, and here we can fetch any value that we want. Okay, so let me just do that. I'll make a few changes. What I'll do is instead of passing all these fields, I'll just simply say that I pass this keyword. Okay, and here instead of string title and string file name, we will have a reference of the curious coder channel. Okay, so here I pass the this keyword. This means that the reference to the current object. So basically the upload video was called by this object, the curious coder channel. Okay, and when the upload video was called, both these fields were populated. Okay, so video title and video file name is populated in this object, and now we are passing this object in the update method. Okay, we have passed the whole object. Using this object, we can fetch the title, we can fetch the file name. Okay, so let me just add a couple of getter methods as well, so that I'll be able to fetch these. So generate getter for video title and video file name. Okay, so in this update, now using this, let me just call it channel. Okay, channel dot get video title. Okay, using this channel, I can say channel dot get video title, and I can say channel dot get video file name. All right, that's it. So now it's a better design. Why? Because let's say we add more fields over here. All we need to do is whenever we are uploading a video, we'll just populate those fields, and in this update we will just send the reference, we will just send the whole object. Okay, we'll send the whole object, and whatever information the subscriber needs, they can just use it from that object. Okay, this is how the design is. All right, now why have I done it like step by step? This is because whenever you study about the observer pattern, you see that in the subject we have a list of observers. Now that is understandable, but then you see that in the update method we have a reference of the subject. Now this becomes confusing, that why do we have that? So that is why I have shown you exactly why, that we pass this, we have this reference of the subject inside the observer. Okay, so there is a one-to-many relationship, as well as we have a reference of this subject inside the observer. Okay, this is why we need it. All right, so I hope it's clear, and I hope why instead of passing all the fields, we can just simply pass the object. Okay, now there is one last change that I will make in this whole design. As of now, this design is not very generic. Why? Because we are saying that we can have only one type of subscriber, which is the YouTube subscriber. But let's say I have my channel on different platforms, maybe on LinkedIn, maybe on Instagram, maybe on Telegram. Okay, so I can have different classes for that. So that is why I should make my design generic. So for that, I'll just add abstraction over it. So I'll simply create an interface called subscriber. Okay, and this interface will have the method void update the curious coder channel. Okay, like this, and I'll make my class implement the subscriber interface. Okay, simple. We just added an abstraction, and this subscriber has this update method. So anytime I want a different type of subscriber, I can just create a class. I could have a class for Instagram subscriber or for Telegram subscriber, any type of follower which I want, and all of them will have to implement this update method, and they will have a reference of the curious coder channel, and they can do whatever implementation they want. Okay, they can use whatever information they want from this curious coder channel. Okay, so I'll make a few changes here as well. Instead of having list of YouTube subscriber, I will have a list of subscriber. Okay, and here also I'll loop on the subscriber list. Okay, we'll have subscriber generic. Okay, I guess that's it. Yeah, here, okay, in the subscribe also we'll have, instead of YouTube subscriber, we can say subscribe. Okay, so these were a few changes that I made in the subject, and let's see the client as well. Okay, everything looks fine. I'll run it again, and great. As you can see, again the video has been uploaded, and we received the notifications for all the subscribers. All right. So as I said, if I want to have another type of subscribers, I can just simply create one more class and they will also have to implement this interface subscriber, and we can just provide the implementation over there. All right. Welcome back, curious coders. Today's topic of discussion is strategy design pattern. It's yet another very important design pattern and it's asked quite a lot in interviews. So just like my previous videos, we'll first understand what problem we are trying to solve and then we'll implement the strategy pattern with real hands-on coding. So let's get started. Suppose we have an interface notification which has this method named send. It has three child classes: email, SMS, and push notification, and all three of them have different implementations. Okay, so far everything is fine. But now let's say I decide to add one more method in this interface. Let's call it encrypt. And suppose email and SMS have the same logic for encryption. Okay, they are using AES encryption, but push notification has a different logic. It is using RSA encryption. Okay, so here you can see that there is duplicacy of code because email and SMS have exactly the same code for this method encrypt, right? And we should avoid duplicacy. Okay, so one solution is that we can divide our interface into two parts. We can have an AES notification interface and a RSA notification interface, and email and SMS can implement from the AES notification, and push notification can implement from the RSA notification. Okay, this is one way of solving this problem. But now let's say in my original interface, I have one more method, let's call it compress. And this time email and push have the same compression logic. They are compressing using zip, and SMS has a different logic. It is compressing using gzip. Okay, so this time email and push are a family and earlier email and SMS were a family. Okay, so you can see that the complexity has increased, and as and when I'll keep on adding more methods and maybe they have different behaviors for different classes, the complexity will increase much more. Okay, so this is where strategy pattern comes into play. So now let's move on to IntelliJ and we'll see how we can actually solve it using strategy pattern. So here we have the problematic design. We have this interface notification which has these three methods and these three child classes. As you can see inside email, we have this encryption logic where we have AES encryption. Similarly in SMS also we have AES encryption. So you'll see that we have code duplicacy. Similarly in email we have zip compression, and in push notification as well we have zip compression. Okay, so again there is code duplicacy. And it's not like that we have duplicate codes in the same set of classes. The problem is that we cannot define a certain set of families as well. Okay, because email shares the encryption logic with this with SMS, and it shares the compression logic with push. Okay, so there is no certain defined set of families. All right, so how to solve this problem? We'll solve it using strategy pattern. The first thing that I'll do is I'll remove these two methods from this interface. Okay, we'll not keep it over here. Okay, I'll just remove them, and instead I'll create separate strategies for them. Okay, so first I'll create an interface. I'll call it compression strategy. Okay, compression strategy. Similarly, I'll create one more interface and I will call it encryption strategy. Okay, so instead of defining them as two methods in the notification, we'll create separate strategies for them. Okay, because these are actually kind of behaviors. Okay, these were two behaviors which were different in different classes. Okay, so I'll show you how it actually works. Now I will have two different classes. First will be AES encryption. Okay, so as of now we have two types of encryption. This is AES encryption and it implements the encryption strategy, and inside the strategy actually I will have this method void encrypt. Okay, so we removed this method from the notification interface and we have added it inside the encryption strategy. All right, similarly we'll also have one more strategy. We have one more child implementation and this one will be RSA encryption. All right, and here I will implement this method. Okay, and the logic for this will be, we already have defined the logic. This is for AES encryption. Okay, so this I will add over here. We implement the encrypt and I add this logic here, and similarly I'll just copy this, and in the RSA encryption I'll just simply say that this is RSA encryption. Okay, so we have an encryption strategy interface which has this method encrypt, and it has two child classes, AES encryption and RSA encryption. Okay, similarly I have already defined this strategy, compression strategy. I'll create child classes of it. Okay, so one compression strategy is zip. Okay, zip implements compression strategy, and here I will actually have the method void compress. Okay, so it will have to implement this method, and I can simply say that system.out.println maybe zip. Okay, similarly we have one more class, and let me call it gzip, and here it will be the same, we will just change the implementation, we'll call it gzip. Okay, so again compression strategy is another interface which will have this method compress, and it will have two different implementations, zip and gzip. Okay, now all we need to do is we need to define these strategies inside this interface notification. Okay, so I will just simply define them. First will be the encryption strategy. Let me call it strategy, or let me call it encryption strategy actually. Encryption strategy. Okay, and actually let's make it a class instead of an interface. Let's create it like an abstract class. Okay, so that I can define these fields, and similarly I will also define which is the other one. This is the compression strategy. Okay, compression strategy. All right, and this method will be abstract void send. Okay, send can be implemented by the child implementations. Okay, like email and this push and SMS, all three have different implementations, so they can directly implement it. Okay, we'll not change this. All right, so these two are the strategies. I can create a constructor for it, generate constructor. Cool. Okay, so this is my notification class. Now I will define a couple of methods as well. We'll have void encrypt. Okay, because we initially we had this method in notification only. Okay, so we'll have this method encrypt, but this time we'll not hardcode any implementation, or will not make the child classes implement this. Instead I'll simply say encryption strategy dot encrypt. Okay, so whatever the strategy is, just use that and call the encrypt method. Okay, similarly I'll have one more method. This will be actually void compress, and here we'll use the compression strategy and we'll call the compress method. Okay, so now I'll have to make a few changes. We have this notification class, so inside the in the child classes, okay, we don't have these methods now. Okay, we don't have encrypt and compress to override, so I will just remove them. We only override send method, and instead of implements actually it will be extends, because it's a abstract class. Okay, and we'll have to define a constructor over here. Okay, so we defined a constructor for encryption strategy and compression strategy, and it will just call the parent constructor. Okay, so this constructor will be called. All right, so I'll make these changes in all these classes. This will be extends notification. I'll remove these two methods from here as well, and again we'll have to define a constructor. Okay, so this will again call the parent constructor. All right, similarly we also have SMS. I'll remove these two methods, and this will not implement, this will extend, and we will create a constructor which calls the parent constructor. Okay, now my design is ready. Now all I need to do is I need to create some objects, and instead of actually hard coding these values, the AES encryption or the compression strategies or everything, okay, I can just define these strategies at runtime. Okay, now I'm able to define these strategies at runtime, and let me show you how. Suppose I have a notification object. This one is email. I'll create an object of email. Okay, now here since I have this constructor, so here I can define the encryption strategy as well as the compression strategy. Okay, so let's say in email what I wanted AES encryption. So I'll say this is AES encryption, and the compression was zip, so I'll say new gzip. Okay, simple. I can define these things at runtime when I'm creating the object. Okay, and now let's say if I want to change it, so I could change it to RSA as well instead of AES. Okay, this is how we can easily define. Similarly, I'll define for other as well. For SMS, we had new SMS, and it was also AES encryption, but it was new gzip. Okay, actually it was new zip over here. And in the third example, it was actually notification. This one is push, and I'll say new push, and it will be new. This one was RSA encryption, and here we had new zip. Okay, this is how I can define three different objects for email, SMS, and push. Okay, and now if I want to call the encrypt, I can, because I have defined these methods in notification. If you remember, we have defined encrypt as well as compress. Okay, so that is what I'm going to do. I'm call email.encrypt and I'll call email.compress. Okay, similarly, we'll simply write sms.encrypt and sms.compress. And in the end, we also have push.encrypt and push.compress. Alright, so we have defined these objects at runtime. We can specify any type of behavior which we want for these objects, and we don't need to make any changes in the notification. Okay, we don't need to, let's say in future, if we are adding a strategy, so we just create one more strategy and we add it over here. Okay, I mean, we have to make that change, but yeah, we don't have to hard code anything. That's what I mean. Okay, and similarly, let's say for this compression strategy, right now we have zip and gzip, but let's say in future we have some different type of compression, so that also we can simply add. We just need to add a child class over here. Okay, so you see how simple this design has become now. I'll just simply run it. Great. AES encryption, then zip, then AES encryption and gzip, and then RSA encryption and zip. Okay, simple. Cool. Welcome back, curious coders. Today's topic of discussion is chain of responsibility design pattern. It's a very interesting design pattern, and frankly, it's quite simple to understand. It's also an important topic for interviews because it's widely used in real world scenarios. So let's start with one such example. Consider a simple support ticket example. Imagine you raised a support ticket because you were facing some issues while ordering the food. So let's say you raised your ticket on a chatbot. Now there could be two possible scenarios. One could be that either the chatbot resolves your issue and the process ends here, or the issue might be too complex and it forwards the request to customer executive. Now again, the customer executive might solve your issue, or the issue could be even more complex and it gets forwarded to the technical team. Okay, now in the end, the technical team resolves your issue. So this is a classic example of chain of responsibility. We have different handlers and all of them are having different responsibilities. But the best part is that if your earlier handlers can resolve your request, then there is no need to bother the remaining handlers. Okay, so this is what chain of responsibility is. Alright, so let's build this example from scratch and go to IntelliJ and we'll perform the whole coding of this operation. Okay. So I'll start with the implementation by creating two classes. First will be a class called client. Second will be a class named issue. Alright, inside this client, I can have a method public void raise issue. And inside this method, we can have a reference of issue as an argument. Alright, now in this class, I'll define a couple of fields. I will have a private string priority. Okay, this is the priority of this issue, and I will have another field private string status. Okay, this defines the status, like whether the issue is pending or it's successful or it's failed. Okay, things like that. So here I can generate getter and setter for these fields like this, and I will also generate a constructor. Alright, cool. So now we have two classes, client and issue. And inside this client, we have a method which raises the issue and it takes issue as a reference. Okay, so first thing is that we need some handlers that will actually handle the issue. So for that, I will create an interface. Let's call it customer support handler. Alright, and it can have a method void handle. Let's call it request, handle request. And this also takes a reference of issue. Alright. Now it will have three implementations. First will be chatbot. This implements the interface customer support handler. Alright, so it will have to implement this method. Okay, similarly we'll have two more implementations. This will be, let's call it customer executive. Alright, and then we will have tech team. Okay, tech team. My bad. Yeah, cool. Alright, so we have three different handlers to handle these requests, and they will have their own implementations. Okay, so let's start with this one. We'll start with the chatbot. So here we can say that if issue dot get priority dot equals, let's say level 1, if the issue is of level 1, then it will be handled by the chatbot, and here we will have some logic, chatbot logic, and after the logic has been done, we can just simply print that chatbot resolved the issue. Okay, and we can say that issue dot set status as success. All right, so this will be the handling of chatbot. Similarly, we can have similar kind of handling in other classes as well. We have a customer executive. So here I will say that issue dot get priority dot equal, if it's level 2, then we'll say that this executive resolved the issue, and again we'll set the status to success. All right, and similarly in the third class, in the tech team, I'll again add this logic, and it will have its own logic, which will be the tech team logic, and it will say that tech team resolved the issue. Okay, here as well I think I didn't add. Okay, here we will have executive logic. All right, so far we have defined their own responsibilities, but we have not formed a chain yet. Okay, chain has not been formed, so let's do that. What we need is that if chatbot can handle this issue, then fine, but if it does not handle the issue, then it has to forward the request to the next handler. Okay, so how can I do that? I will simply define a reference of customer support handler over here, and I can simply customer support handler, and I can simply create a constructor, and I can say that this dot, okay, not like this initially, I'll simply do it like this, public chatbot, and here I can say that whichever is the next handler. So next handler is actually customer executive. All right, so right now I have done tight coupling. We have tightly coupled chatbot with this customer executive, but later on I'll improve this design. For now I'm doing it like this for simplicity. Okay, so we have taken a customer support handler, which is the customer executive, and it just says that if chatbot can handle the request, then it's fine. Otherwise we'll take this handler, and using this handler I can say handle request, and here I will pass the issue. Okay, get it? So here we are handling the request, and here we are saying that if chatbot cannot handle the request, then we should move this request to the next handler. Okay, and the next handler in this case is the customer executive. Okay, similarly I'll make the changes in this class as well. Here as well I will simply first take private customer support handler, let's call it handler, and I can say public customer in the customer executive, and in the constructor I'll simply define handler as the next one, which is the tech team. Okay, now here using this tech team, using this handler, I will just call handle request, and we will pass on the issue. Okay, so this is how chain has been formed, and I'll do a couple of things as well. I can say that issue dot set status can be set to pending. Okay, because the request has not been closed yet, so it is set to pending. And here as well in this chatbot also I will add issue dot set status as pending. Okay, and we can also add a logger here. I'll simply say that chatbot could not resolve the issue, moving to the next handler. Okay, something like this. All right, similarly I'll add this in the customer executive, that executive could not resolve the issue, moving to the next handler. All right, now in the last handler, what we are going to do, I'll simply say that if it can handle it, and actually it should be level 3 over here. So I'll say that if it can handle it, then it's fine. Otherwise we don't have any more handlers, and the issue cannot be resolved at all. So I'll simply say issue could not be resolved. Okay, and I can say issue dot set status as failed. All right, so this is the chain of responsibility design. We have a handler interface whom three classes are implementing. We have a chatbot, we have a customer executive, and we have a tech team. Okay, all of them have their own implementations. We have set up a priority, and on the basis of priority we are deciding which handler will handle the request. So chatbot will handle only level 1 request. If we have a different level, it will send it to the next handler. Next handler we have tightly coupled over here, which is the customer executive. So request comes to the customer executive. Now if the priority is level 2, it will handle it. Otherwise it will pass on to the next handler, which in this case is tech team. Okay, so it is the last handler. It will handle if the level is 3, and if we have a different level altogether, then that request cannot be handled, and we can say issue could not be resolved. Okay, so now I'll just simply start with the client. Client will start with chatbot. So again, I'll take a reference of customer support handler like this, and in the constructor of this client, I can say that this handler is equal to new chatbot. Okay, because client will be starting with the chatbot. All right, now using this handler, it will call handle request and we will pass the issue. All right, now in the main, I can simply create an object of client equal to new client, and using this I can call client.raiseIssue, and here we'll pass an issue, new issue, and it will have, let's say the level is 1 for now. Okay, I've set the priority as 1, and let's call the status as initiated. Okay, the request has been initiated. All right, cool. So let me just run this project, and great, since the level was 1, so chatbot resolved the issue. Now let's say the level is 2. So in this case, chatbot could not resolve the issue. Moving to the next handler, executive resolved the issue. Similarly, if the level is 3, this time both chatbot as well as executive cannot resolve the issue. Tech team will resolve the issue eventually. Okay, so this is how chain of responsibility pattern works. Now, as I said, I'm going to do a couple of improvements in this design. So fun thing is that we have hard coded all this. Okay, we have hard coded the next handler, and we should actually not do that. We should have a flexibility of defining this at runtime. Okay, so I don't have to make much change. What I'll do is I'll simply actually have a constructor over here. All right, we can set up a constructor, and in this constructor we'll pass the handler, and it will be the next handler. Okay, it will be set up at runtime. All right, similarly I'll make these changes in all the classes in chatbot as well. I'll remove this constructor and I'll create another constructor which takes this handler as an argument, and we define it at runtime. Okay, similarly in the client also, we don't need to hard code it with chatbot. We'll actually let it be decided at runtime. All right, so now in the main I'll make a couple of changes. I'll not write it like this. Actually, when I declare a client, now here I can define which particular handler I want. Okay, so I want chatbot, let's say. So here I define chatbot. Now the next handler for chatbot will be customer executive, and inside this it will be new tech team. Okay, so this is how I can make the changes. I'll just run it, and you see that it works. All right, so now this gives me the flexibility that I can even change this thing. Maybe I don't want to include chatbot at all. Okay, so I can just start it with new customer executive as well. This is also allowed. All right, so let's say in future I didn't want chatbot, so I just have to make this minimal change and I'll run it again. So executive team could not resolve, tech team resolved the issue. Okay, and in fact I can even change their order. Maybe I can have new chatbot here, and maybe here I can have new tech team. Okay, so new tech team. So as you can see, I've changed the order altogether. All right, I know it doesn't make sense, because why would we first go to customer executive, then chatbot, and then to the tech team? Yes, it doesn't make sense in this example, but still we should have the flexibility to do so. All right, so this is it. This was all about chain of responsibility design pattern. I hope this video was helpful. For more such content, please follow my channel, The Curious Coder.